Discovery, go at throttle up. Discovery, go at throttle up.
Alright, let's get rolling. How's everybody doing today? Whew. The streaming market will eventually be... What is this? What's the conversation you guys are having? The streaming market will eventually crash and be consolidated. You know what would be a really smart thing to do? Take all these streaming services, and then bundle them all together. And then have a master subscription to all of these services. Sounds like a cable company. Yeah, I know. Cable is too expensive for YouTube for what you get. I have that's what I was trying to say. I have YouTube TV. YouTube TV is just fine. That works. It's the circle of life. Yeah, that's right. More aurores are possible tonight and later this week. Shut that off for a second. Anyway. Oh, nice. That's cool, man. You're also odd, so there's that. Odd or old? Because, yes. Yeah. Anyway, truck update. I got all the bolts and all the hardware that I need. If you guys look, there's some paper down up there because I started cleaning and painting parts this morning. Still not 100% sure what we're gonna do about the about those bolts not being all the way through. Now, don't get me wrong, we're still got to address that problem. There's no way I'm leaving it like that. Yeah, I'm thinking about how I want to do it. Because that front axle, the front solid axle is really grimy. And I kind of feel bad bolting nice clean parts to a grimy front axle. So maybe we should fix it. Clean it up a little bit. And then, I suppose when we do that, we'll take apart the brakes, stuff like that. Repack the wheel bearings and then fix those stupid bolts. I still can't believe that. We found bolts that are holding the front brake caliper bracket to the spindle that were not long enough, and they were maybe about a quarter of a way through the nylock nut. So the bolt was barely holding on, literally by a thread. Yeah. I don't know if that's intentional or not, but the nylock nut doesn't work very well if you don't use the nylock. Only in the U.S.? It's an aftermarket brake kit, a la carte. It's not supposed to do that. Also, my uncle worked on this truck before me, you jerk. Spiffy, I saw it and immediately went dead cold. I'm like, oh, wow. Dude, I ain't even mad. I am really happy we took this apart now. How many vehicles you got? 5. In this case, do not buy on AliExpress. Yeah, Spiffy, I saw it and I went, oh. Wow, I'm really happy we took this apart. That's really good. So yeah, the front axle is out of the truck. You can see it right here. It's sitting on that dolly right there. 5, something new? Primo's car, make. Nothing new. Honestly, guys, so let's be real. Carcane is an addiction, and it's an addiction that never goes away. I'll always want to buy another car. But honestly, I have enough cars right now to play with all different types of things. I have trucks, I have sedans. We have a coupe. We have a sports car. Like, dude, I have enough to keep me occupied for a long time. And now I have the shop to work on them, too. So, yeah. You're probably not going to see many new car purchases from me for a little while. Same boat with that welded nut that I saw. It wasn't welded, dude. It was just grimy. Reminder, Falcon 9 from Vandy with 51 Starlinks at 409. Yep. When you start making little EJs, you'll have to add a minivan to the fleet. Maybe an original Aerostar. Bronco. Actually, you know what I would really like to find? A Centurion, a Ford Centurion, which is probably a little bit pricey. But man, are they cool. Check it out. So a Centurion is when you take a long wheelbase Ford. So the truck came in like 3 different wheelbases. There's short, medium, and long. You take the long wheelbase, you put a quad cab on it, and you graft a Bronco to the back of it. The back from the Bronco. I'd want a Centurion. Yeah. Centurions are very, very cool. It's basically a Suburban, Chevy Suburban, but with Ford. And with cool OBS parts. Yeah, see? Let me guess. Your cars combined are worth more than your house. No, Erudite, not at all. My cars are rare, but they're rare for the wrong reasons. Like they except for the truck. Okay, so the 59 is rare. The 59 is worth something, but it's not worth a lot. The Mustang is probably the car that's worth the most in my fleet. Yeah, that's not even worth a lot. The Coronet's not worth a lot. This really isn't worth too much. Yeah, rare for the wrong reasons is... that's not... You know what? That's not really the right way to say it. There's just a lot of them. There's a lot of Mustangs. A lot of OBS Fords. And... yeah, they were just kind of used and thrown away. You know... Especially the truck, the 97. Like, people just use them as work trucks and just beat the snot out of them, and that's it. I would say I'm not even close to 50 Gs. They're not worth a lot because cars are so... I mean, like I said, some of them are rare for the wrong reasons. The Coronet's rare for the wrong reason because no one wants a 4-door. No one wants a 4-door Coronet. Who cares? It has 4 doors. But see, the funny thing is that with modern technology, you can make any car fast. You can make any car very, very fast. So, I don't really care how many doors it has, to be honest with you. The Dodge is pretty rare, but yeah, like I said, that one's rare for the wrong reasons. The 59 is also rare for the wrong reasons because 3rd Gen F-Series just got the snot beaten out of him and then nobody cared after that. They threw them all away because they were junk. Because they just got tired and they said, Matt, buy another truck. The 97 is a work vehicle. It was a tradesman's truck. So a tradesman electrician in Southern California used that truck for a very long time. Put it had 170,000 miles on it when I started Route 154. It's got 176,000 miles on it. That's like, what is that, like 300,000 kilometers? It's got a lot on it. It's an old truck. So like all the cars are kind of rare for the wrong reasons, or they just made so many of them that it's not really... Yeah, rare for the wrong reasons is kind of the right way to say it. How many times around Earth? 3. Yeah, 3 times. That truck has driven around the equator 3 times. Just think of how BA is socketed. Dude, the Centurion is money, dude. I want one of these. I will find one. I think that's awesome. Can you imagine, Helvis, you imagine one of these with an IDI in it? Or, dude, one of these with like a 6BT in it would be... Oh. And you know, like, when I was younger, I used to hate on people that had Suburbans. Like, I'm like, why do you need that big of a car? Why do you need that big of a car? Well, first of all, they need that big of a car because shut up, EJ. That's why they need it. It's not any of your business why they need that big of a car. Second of all, that thing is super handy because you can carry a bunch of stuff in it and also carry kids in it, and it's a really big truck. If there is some kind of problem, you know, God forbid, some kind of problem, you're most likely running the other person over. See? No. Nearly. This isn't... you know what's messed up, man? That's not a tiny PP car in the U.S. That's not. It's really not. That is actually really nice. That's a nice, tastefully done off-road vehicle. Think like... So instead of Nivas, we have those. Yeah, those old 4x4 trucks, dude. It's like an UAZ, basically. Not so much a Niva. It's not a Niva at all. It's an UAZ. It's just a bigger one. Same idea. You want to see compensation? Here, I'll show you. These are tiny PP trucks. See that? That's compensating. Stop, I'm eating. Oh, sorry, my bad. Dude, I respect the hustle. Like, I don't like hating on anything. That's actually kind of nice. It's very tastefully done. Too bad it's a Chevy. But, yeah, I don't just... It never kind of... Like, it just doesn't do it for me. Like, a truck that... You're taking a truck which is designed for work, right? And designed for off-roading and whatnot, right? And you literally make it worse at doing every single one of those things to make it look nicer. Well, look nicer. But you know, either way, it goes back to it, man. You know, we could judge people all they want, but at the end of the day, your car is your canvas, right? You do whatever you want with it.
Go at throttle up.
Show the semis converted into pickups. Oh, dude, I like those. I like those trucks. All right, I think they're cool. Oh, it's a guilty pleasure, man. It's a guilty. It really is. It really. Like that F750. I love those things. Those things are really neat. If you fifth wheel with it, then it's just fine. Like, oh, that's so cool. Whistling? I like Whistling. Whistling's a good dude. Yeah, that guy's cool. I didn't get it at first, to be honest with you. I didn't get it. I was like, why are you wrecking stuff that you bought? That makes no sense. And then I kind of got like what that channel's all about. And I like it, dude. I watch all his videos. It's pretty damn funny, actually. So, like, nearly, this is what I'm talking about. Like, some people take these things. Some people take stuff like this, and they daily drive that, which is just, all right. Like, you know, that's cool if you want to daily drive that around, I suppose. Just really, I mean, all right. Now, see, the reason why people buy this, the other reason is, like, if you work on a farm, this is a super useful piece of equipment. Like, this can tow stuff around. It can tow heavy-duty stuff. So, like, it's got a, you know, if you put a gnarly tow hitch on this or a fifth wheel, then it's useful. Super useful. Which is why I don't really have that big of a problem with it. I kind of like it. You know, but then again, you know, obviously something gets lost in the translation, and then people end up doing stuff like that. Once again, hey, you know, everybody has their own thing with trucks, you know. See, me, this is good enough. See what I'm talking about? This is fine. This is just a good off-road vehicle, man. Dude, you don't even want to know some of the stuff we've seen over here. Oh. Dude, it's some... You guys won't like it. You guys won't like it. Oh yeah. Yeah, that's nice. Oh yeah. But see, for every weird, stupid looking thing, you get something cool like this. It's a 71 Charger or 71 Super B. Not a fan of the decal. That's an AAR decal, Mutter. It's here. Look, I'll show you. It's an all-American Cuba. It's the AAR stripe. Mopar did that from the factory in the 70s. That's actually not the AAR stripe. It's the oh, I don't know what it's called. Pro touring, dude. I want to do a pro touring with the Coronet. Dude, seriously, make the Coronet into a grand touring vehicle. That would be hilarious. No one would see it coming. That's what I want to do with that car. I want the Coronet to basically be something like, here's how I like doing cars, fellas. I want to make a car fast. You know, you want to make it handle good. Not the truck. The truck is a truck. Like, if I have a car, I want to make it handle. You want to make it go faster, everything. But here's the thing. I want to make the car bulletproof. Not literally. I want systems, over-engineered systems on board that are literally... So put an engine in it that is designed to make like 700 horsepower and make it make half of that. 500. Make it make 500 horsepower. That's not half, but you get the idea, right? Don't, like, purposely detune the engines and do exactly what SpaceX does with Raptor engines, for instance, right? Raptor engines were, or like the Merlin engine is another good example. Merlins never have hit their theoretical maximum, right? Tom Mueller purposely over-engineered them in Elon, they purposely over-engineered it, so down the road, when they go to reuse the engines, they don't eat themselves to death. I mean, Raptors kind of have that problem, but so like purposefully like have a lower duty cycle on the engine, I guess. So you could make you make a car that's fast enough that literally can go anywhere. You could drive it anywhere and it'll never break. It'll never have a mechanical problem. Is that next after the truck? Hey, all systems, 67 months. I'm not sure what we're gonna do after the truck. I do have work to do on the 97. We gotta finish getting the stupid paint off that thing so I can get the whole thing white again. Make it do 1 out of 154 what it can do. Bingo, nearly. That's how I like building my cars. I like building them to know that they're going to, like, I'm not gonna you shoot a spark plug out the side of the car, you know. Yeah, and the Coronet I want to do a pro touring with. I want to pro tour it. I think like we should. So I might have a line on a 440 for that thing. Thinking 440 with like a sniper on it or something would be pretty freaking cool. Would detuning a souped-up engine be more efficient than a low-power engine like a Prius? It depends on the application, dude. You need to build the streaming rig into the 97. Yep. You have a GT350 with 1,000 horsepower and plan on building the block for 1,500 so it can easily handle its current horsepower. Yeah, there you go. Exactly. That's how you build. You know, there's guys out there that, you know, like, oh, my transmission could take 400 horsepower, so I'm going to make it have 400 horsepower. I'm like, no, that's a real good way to break a transmission. You know what I mean? That's a real good way to do that. Yeah, can you imagine 440? A 440 in that thing? With heads, mild cam, and then electronic fuel injection, dude. And then, like, the QA1 suspension kit for it. Isn't a 440 like 6.5 liters? No, it's 7.3, I think. 7.3 liter. How was the stag party? Have you recovered? Was it the F1 race? No, I went to Vegas. I saw the F1 paddock at Vegas. In Vegas, does that help? So it kind of was an F1 thing. It's just I was off by a couple of months. You never remember the conversion. So how I do it, Shaw, is 400 is 7.3. 400 cubic inches is 7.3. So 440, actually, hold on. I know that 5 liters is 302 cubic inches because of Ford. And I think a 383 is a 6.6 liter. Here, let's check. So if we go 302 cubic inches, yeah, 4.9. So we go 305. 305 is 305 cubic inches is basically 5 liters. We go over here. Let's go 7.3. Yep. Okay, so I was wrong. 6.8. 6.8 is 400 if I'm looking at this right. Yep. What about 6.6? Oh no, 6.6. There you go. 6.8. There you go. 7.0. All right. The biggest motor was Ford's 460, which I believe that's the biggest motor that I can think of that they put in a truck. Ford's big block was the biggest displacement. Chrysler has 440, Chevy has 454, and then Ford has 460. It's 7.5 liter. Hell yeah. Hell yeah. Chevy has huge crate engines, dude. They have the crate engine. They have like a 572 Chevy and then like a 632 Chevy, which is all right. The 632 is nuts, dude. That motor is insane. Yeah, that's right, Tessa. There's the V10s. Ford made a 6.8 liter V10, and yeah, Dodge had that 8 liter V10, and then Lamborghini got a hold of it, and that's how we got the Viper engine. True story. Yeah, I always use 5 liter. 302 is 5 liters. Basically 300 cubic inches is about 5 liters. And then I kind of go from there. It's like a diesel engine. Yep. We made some big freaking motors, man. Big motors. Anyway. The Vegas race is going to be on Christian Horner's 50th birthday. He'll probably win. I like Horner. Horner's a good dude. I don't mind him. More volume, more fuel use. Not necessarily, Forlorn. It's all about how you drive it. It really is. It's all about how you drive it. The 97, when I was moving down here, because manual transmission, and this is why I told Blue Fairy, it really depends on what you're doing. Really depends. The 97 has a 5.8 liter in it. It's a 351 cubic inches, right? So 5.8 liters, and it's got a 5-speed behind it, and a 410 rear gear. I got 25 miles to the gallon in 5th gear. 25. In a truck that weighs 6,000 pounds. Guys, my 97 is a heavy-duty vehicle. It weighs 3,000 kilos for the metric folks. 3,000 kilograms. Yeah, it's heavy. Cornet with the diesel chugging sound. People have put 6BTs in Coronets before, Buck. I think like a nice 5.7 in that thing could do you right. That would be a pain to wire that all up. Save up for a JRI Viking suspension. Viking has auto-adjusting suspension these days. Yep. You had a 351 and a Mercury Montego. Nice. Also depends on the fuel type. That's right, Begin. Yep. Exactly. So, like, here's the thing. You guys, you know what's funny, dudes? Like, you want to know a car that gets great fuel economy? Here, check this out. Let me think. Here. I know of a car from the 60s that gets great fuel economy. This thing right here. This thing with the Gen 1 Ford Falcon. Great fuel economy. This guy right here. Beautiful car. It's a McNamara car, though. McNamara is kind of... Yep. Falcons are great cars. And they have a... Yeah, see, there you go. They come with a 2.4 liter inline 6 in it. Inline 6, very smooth. You get 50 miles to the gallon in this thing. If it came with a 4-speed manual with a 144, 40 miles to the gallon, 50 miles to the gallon all day, no problem. Actually, I'd like to do that. I'd like to take an old Falcon, get a Gen 1 Falcon, and make it a fuel economy car with a carburetor. That'd be funny as hell. People would get mad at that. F100 with a 30. Ooh. Let's see. Oh, whoa! What is this thing? Oh, man. Alright. Dude. That's not a lowrider, W. This is a pro touring truck with a freaking Barra in it. Look at that. Custom suspension. Custom coils in the front. And then... What is that? What is this? Look at that 4-link. Whoa! Yo, dude. That's some beef right there. Holy crap. I'll show you a lowrider. I love lowriders, Aussie. For real, dude. I love them. Lowriders are cool, man. And for what it's worth, I like donks too, which is very strange. Like you wouldn't expect that from me, but those are cool, man. So check this out. See how thick that thing is? That right there is basically a strut, guys, to make sure, like picture a strut in Kerbal. It's a strut to hold this whole thing together to make sure that the axle doesn't twist out of the back of the car when you go to apply power. This right here should tell you everything you need to know. The sway bar is like baseball sized. That means it makes a lot of power. And yeah, still running drums on the back. Yeah, those are Ford 10-inch drums. I have the same drums on the back of my truck, which is weird. But all right. That's cool. It's right-hand drive. Well, that would explain the Barra motor in there. Cool. Neato burrito. Anyway, so I started us off with Space and Rocket review. Guys, I'm like not sure what we should do because we absolutely thrashed on the KSP challenge yesterday. I got it done in like 7 hours, which is pretty cool. I'm pretty happy about that. One more? Alright. Alright. One more. Hearts, Wings Wednesday. Ooh. Wings Wednesday, I don't mind. How about we do some Wings Wednesday? Maybe some hearts? I gotta work on the truck tonight, though. We'll see. What is this? Oh, that's cool. Nice. The Fiat S76. Yeah, that's that 8-liter... That 8-liter freaking 28.4 liter 4-banger. All right. It's got an SR20 in it. Dude, red top. That's cool. Weird looking car, but it is cool. Nice. That's right. We got the RS-25 test at 2. That's right. And then we got a Falcon launch. We got a Falcon 9 launch at 4. So, yeah, we got some... I don't know. Always love some hearts. Wings Wednesday F104 build. I could do Wings Wednesday. I could do that. Aussie, what do you got? Oh, that's sick. I love it. Dude, that paint job is money. Oh, that's cool. Dude, the spec paint is awesome. I love it. That's so good, man. Dude, you can hear it. Garage is a bit of a mess. So was mine, dude. Don't worry about it. But you can hear it. You can hear it. That's cool, man. I dig it. LS, by the way, I don't dig it. Get it off my screen. Oh, boy. Are there, Ozzy, are there a lot of those dent side trucks down there? DMCA warning. Why would I click on that, W? Wheels alone cost more than the truck. Fit, I think that paint job is a little bit on the expensive side. This has an LS in it. What? What? Not too many of them around. I was gonna say, dude. Oh my goodness. Oh, okay. I hope it's a dry sump. Huh. That is, in fact, an LS engine, yeah. Interesting. Velocity, I saw one yesterday for 84K. I don't know what any of this is, but I did tie my shoes all by yourself this morning. Okay. Okay. We did build the F4 Phantom. Maybe we should make this. We should be able to do it with the procedural wings. This actually shouldn't be too hard to make. I mean, it does have a J79 in it. Were those fuel pods? The F-104 can carry fuel tanks on the wingtips, yep. Mm-hmm. So, Kelly Johnson designed this plane, the same guy that designed the SR-71, and the Lockheed Constellation, and the P-38, and the U-2. In fact, you guys want to hear something interesting? If you don't know, Kelly Johnson designed this plane first. He designed the Starfighter first, the F-104. Want to hear something nuts? A U-2 is just an extended fuselage F-104 with bigger wings. True story. I know about NF-104A, Rendezvous. I know about that one. Yeah. Yeah. A lot of people don't know that. It's an F-104 with different intakes, different nose, bigger wings. It's an F-104 chassis. Yeah. Interesting, right? Not a lot of people know that. Look at it. Look at the back. Very, very, very important. Dude, it's the same plane. Crazy, right? Yeah. When they went to make the U-2, they needed something light. The F-104 is extremely light. Yeah. A U-2 is an F-104. Yeah. Dude. I'm surprised. Different engine, though? I don't think so. I'm not sure. Maybe. Let me check. Jim, I have to double check it now. Yeah, it's got an F-118. Okay. Non-afterburning turbofan. It's derived from the GE F-110. It's an F-104 with body kit and wings. Dude, I'm serious. It is an F-104 fuselage that they extended. Like, don't get me wrong. They didn't take F-104s and make them into U-2s. They started with an F-104 and started making modifications to it to make it a high-altitude vehicle. But it is, at its bones, an F-104. Pretty cool, huh? There's an F-104 that a civilian owned, and it needs 40 maintenance hours per hour of flight. An F-104? Really? What type of maintenance are we talking about here, Fit? Oh. Oh, hello. Like, I mean... I think they said the U-2 will retire in 2026. That's stupid. Oh! Oh, mama! Oh, my favorite. Oh, I want it. What do we have to replace the U-2? The RQ-4 basically does the same thing with nobody on board. Oh, look, Junk, you get the frick out of here, man. F-4s are gigantic, dude. It's a big fricking plane. Oh, yeah. Yeah, buddy. What is this site? Trade a plane. Oh no. Oh no. Oh no. An A4. Oh no. Oh, this is bad. 3.3 million for an F4U. Damn. Yo, whoa, that's kind of rare. A real hurricane. Look at that. 2.2 mil for a hurricane. I'm wondering about that Carmen Gia. I'm wondering about that Carmen Gia, but whatever. Oh, a Sky Raider. 750 Gs, that's it? That's sick, dude. Sky Raiders are cool. '57 ME 109. Now, who knows their history? How could there be a Messerschmitt 109, a plane that was designed during the Nazi era in Germany? How could there be one from 1957? Who knows? Who knows? Who knows their history? I know about EAA Act, and we'll go there one time. South America? No, but good guess. Argentina, the design was licensed. That's part of it. Built from parts are technically licensed. They did not sell their planes to Argentina. Spain. That's right. Yeah. Rendezvous, you know. That's right. Spain. Francisco Franco was buddies with Mustache Man. The guy that shot himself in the face and they burned his corpse and they had to identify him by his dental records. Yeah, that guy. Yeah, he's kind of a dick. They were buddies. He licensed the Messerschmitt design to the Spaniards, and the Spaniards were making ME 109s well into the 50s. That's why that plane's from 1957, but it's a World War II airplane. Pretty cool, huh? It's a real one. It's real. It's just license built, but it's real. Want to know about crazy engineering? There were certain versions of an ME 109 that had a cannon mounted right here. Seriously, there's a cannon mounted behind the engine. Behind the engine. So I know what you're saying. How the heck does that work? Oh, the barrel goes through the engine. Yeah, because German. Yep. The barrel goes through the engine and comes out the nose of the propeller because Germany. No, not synced firing, dimit. No interrupter needed. It goes through it. The barrel comes out right there. That's the tip of a gun. Yeah. I have an idea, Hans. Oh yeah, what? We will make the barrel go through the engine. Why? Why go through the engine? That's very complicated, yeah. But you will be able to see where your gun is going and you won't need to worry about interrupting and hitting the propeller. Ah, wunderbar. Ist gut. No, seriously, there's a cannon mounted right here, and the gun barrel goes through the engine block and out the propeller. Pretty cool, huh? Same for the P-39. Yeah, but the P-39 is a little bit different. The P-39 doesn't have a gun barrel going through the engine block. P-39 is definitely a weird one, though. Bell actually came up with a similar design, but the thing about the P-39 is that... all these pictures are poo-poo. Yep. The thing about the P-39 is that those bullets only have to go through a drive shaft. That's it. Because... look at this picture. Very interesting thing going on here with the P-39. The engine is behind the pilot. It's a rear-engine airplane. With a propeller at the front, though. The drive shaft literally goes around the cockpit and comes up and through. Yep. And the gun is right there. That was Bell's solution to the same problem. Put the engine behind the pilot. So the ME-109 goes pilot, cannon, engine, propeller. This thing goes engine, pilot, cannon, propeller. Weird, huh? I would definitely have a Focke-Wulf 190 over the ME-109. Oh, yeah. No. Yeah, I agree. The Focke-Wulf was better. The 109 was a good plane. Focke-Wulf was better air superiority. But nothing stunts on the P-38, though. I mean, it's a different country, but yeah. You guys want another crazy one? Here, check this out. So the P-38, made by Kelly Johnson, the same guy that made this plane, the F-104. He designed this when he was 27 years old. 27. He designed the P-38. The P-38 was basically a heavy fighter that was made by Lockheed, and it seriously is pretty much my favorite plane like heavy fighter plane from World War II. I like P-38s and I like de Havilland Mosquitoes because speed is king, right? P-61. Ooh, Harry, you are a man of taste, I see. Very nice. Goff Mosquito. The Mosquito and the P-38 are basically the same idea. That's why I like both of them. Yeah, the Mosquito's probably in a close second behind the P-38, and then a P-47 behind that. So, check this out. So, these things have Allison 1710s, V1710s in them. The same engine as the P-40. Right? It's not Lockheed, it's a Curtiss. So the P-40 wasn't a bad plane, but it was a plane designed from the late 30s. Not bad for its time, right? But the P-40 was notoriously underpowered for what it was. It was an okay plane. It's a good plane for 1935. It's a terrible plane by 1935 standards. It's a good plane. By 1945 standards, it's a piece of junk. Might as well be flying around in a Cessna, right? So Kelly Johnson looked at this, and if you look at the P-38, the cowls on the front, it's the same motor. Those look like the front of a P-40, right? But Kelly Johnson came up with this crazy idea. If they were somehow able... Now, centrifugal supercharging was absolutely a thing, right? That was absolutely a thing that planes were doing, right? A lot of engines like the V1710 had a drive shaft supercharger, right? So you could put more air into the plane at high altitude, right, and get better performance. Kelly Johnson looked at that and said, well, it's still underpowered. So he incorporated this new type of thing called turbines into the design. P-38s are turbo supercharged. Two-stage turbocharging. They're turbo supercharged. Yeah, not a lot of people know that. With intercoolers, that's what these are in the back. It's a turbo supercharged intercooler. This guy was coming up with turbo supercharging in the late 30s when he was in his 20s. So this Allison V1710 engine with turbos and superchargers on it, ended up making it a really good freaking engine. And the P-38 was one of the fastest planes around at the time. Yeah, turbo supercharging. Yep. That's why the P-38 is cool, because Kelly Johnson was incorporating turbine technology, basically the predecessor of jet engines, into his designs. Basically, when he was in his 20s. Dude, I designed something like that in Kerbal when I was 27, so there's that. Crazy, right? Dude must have been an alien. Yeah. Right? I mean, dude, who else is making designs like this in the late 30s? No one's building stuff like this in the 30s. Not even close. Yeah, did it without a computer. Did it by literally drawing it on a piece of paper. The XF-84. Oh, the Goblin. My image. That's a good call. What fuel did most World War II planes use? Gasoline? These ones use gasoline, but the Germans, because Germany, the ME-109 uses diesel, if I'm remembering right. So something that militaries, actually, this is kind of something that the Germans had, that was a really good idea, and something that the U.S. does too, now, we do it nowadays. You standardize your power needs and you standardize your propellant needs. This is why Abrams tanks, for instance, run off jet fuel. Because if the Abrams tank ran off diesel and a helicopter ran off jet fuel, right? That creates a logistical nightmare. Because the Abrams, for instance, runs off the same thing that the Black Hawk runs off. You only have to move one type of fuel around. Pretty smart, right? It was low-octane gasoline. Okay, cool. Are you sure it's not diesel? I could have recalled that. I seem to recall that there was a diesel version of that plane. Could be wrong, though. It's nuts that they still use leaded fuel for aviation. Ju-86 had diesel. Some German plane. Isn't jet fuel much more expensive? I mean, Kem, if you make a lot of it, probably not. Probably not. And we do like that oil over here. Tasty. Tasty dinosaur juice. It's great. I mean, if you make a lot of it, then no. And I guarantee you that it's probably going to end up being cheaper than refining 2 fuels instead of 1, right? It's actually really freaking smart. And the crazy thing is that if I'm understanding this right, like all U.S. military equipment uses the same voltage. They all use like 24 volts. So I could be wrong. If there's somebody out there, please correct me on this one. They all use the same voltage, so you could use a Humvee to jumpstart like a helicopter or something, or vice versa. Like you could jumpstart a tank with a Humvee because they all use similar power systems. Which is really freaking smart. That's really smart. Really, really smart stuff. If I recall correctly, German tanks ran on diesel, not gasoline. I don't remember. See, the U.S. experimented with this idea with Shermans. A lot of people don't know that Sherman tanks actually have an aircraft engine in them. And we promptly learned why that's not a good idea, to make your tank run off gasoline. The Germans had a slang term for the M4. The Germans called it the Tommy cooker. Because if you hit it in the right spot, it will literally just explode. Yeah. Because aviation fuel is highly flammable. Yeah. You were onto something. It's the jets that the Germans made that ran off diesel. Yeah, okay, Pasquale. I knew it was something. Thank you. I knew I heard that somewhere. I thought it was the 109, but I'm clearly mistaken. Yeah.
Discovery, go at throttle up.
Hey, Linux, 33 months. Tanks again. Will we talk about this? Oh, you guys want to talk about VAST, don't you? Yeah, we had some pretty hardcore space news come out today. Here. I have a video for you if you want to see it. This is pretty cool, man. Here, check this out. The Zeppelins were also diesel. All tanks burn if you hit them in the right spot. Yeah. Is Elon finally leaving Earth? I don't think so. Some burn more than others. Yeah, Kem, and some of them, when you hit them in the right spot, you know, end up making a nice combustion chamber. And that ends up, you know, popping the turret off. It flies up into the air. Some tanks. I'm not saying which. Not saying which. See, the Abrams tank has blowout panels on the top. So if you hit it and you hit the magazine, it blows upward and not into where the crew is. Other tanks, can't speak for other tanks. The Panzer IV used a 12-liter gasoline engine. The Panther and the Tigers used a 23-liter gasoline engine. And Anis, my favorite German tank is not the Tiger. I think the Tiger's too heavy. Panther is where it's at, man. That's a nice tank. And I know. Everyone's gonna be like, "Oh, but the mechanics, the mechanics of BJ." Yeah, yeah, I get it. It's complicated, but I like it. Okay. I prefer the majestic Puma. IS-2. Good call. How big of a gun do you want, Sebastian? Yes. how big of a gun do you want? Duh. Okay. T-34-85. Long barrel T-34. Good call. Another good tank. If it looks the best, it's my favorite. Dude, you can't... The Panther, you can't stunt on that. It looks amazing. That... Dude, it is a beautiful tank. Look at this thing. Hello. Nice. Very nice. I'll get to the space news in a second. The T-34 was in a Russian parade yesterday. Yeah. Interestingly enough, Erudite, that is a Soviet T-34 that was actually... That's not like a post-war T-34. If I'm understanding the serial number on that tank correctly, that tank... I don't know if it actually... I don't remember. I'd have to go read about it again. I don't remember if it served on the Eastern Front. I don't think that it did. I think it was made not in time for the war. And then that T-34 was sold to Laos, a country in Southeast Indochina, right? So like Laos, Vietnam, Thailand, it was sold to Laos. They bought 30 T-34s from the Soviets a long time ago, and they still fielded them until the Russians bought them back. They bought back the T-34s like I think it was 2 to 3 years ago. So that T-34 is like legit. That's real. That's a real one. I mean, obviously it's a real one, but still, it's kind of cool to see like that a World War II tank still in good working order. Give me a Centurion all day. Well, you're comparing tanks from different eras now. I mean, you could take your Centurion. I'll take my M60. Heavy losses. They need the T-34s back. I can't speak to that, dude. I haven't been following what's going on there. Deal when you're shipping it to you. Actually, Tessa, I think, we were talking about Whistling Diesel a little bit earlier. I think Cody bought a Centurion. I think he bought one. Like, bought one. Yeah, here. Look at the YouTube thumbnail. TLDR, it's a meat grinder stalemate. Oof. I think that's a chieftain. It's a chieftain, right? That's a chieftain. That's not a, is it a Centurion? I'm not even sure. Either way, Cody bought a tank because... See, this is what I like about Whistling, alright? I cannot sit here and say, like, if I wasn't making millions of dollars off my YouTube channel, that I would not buy a tank and flex on people with my frigging tank. I would absolutely do that. Oh, yeah. Like, yeah, absolutely. The Chieftain is the 80s, the Centurion was the 40s and 50s. Nice. How far did the Soviets get with the flying tanks and submarine tanks? Not very far. I saw a chieftain dressed as an Abrams crush a car in Vegas when I was there. Nice. Nice. Only with flying turrets. Cam, you ever see that they found one of those turrets on the 5th floor of an apartment block? I'm serious. This was from like a year ago. Guy literally opened his door to get into his flat, opened it, and there's a freaking tank turret sitting in his living room on the 5th floor. You might want to reconsider that autoloader design. Yeah. I saw somebody post that a long time ago. Yeah, the T-72, that autoloader, not the best. All British tanks come with the most important piece of kit, though. They all come standard with boiling water vessels to going back to the originals. They have a kettle on board. You guys would do that. Some calculated heights up to 80 meters for turret loss. Yes, to make tea. I know. Wouldn't you put a coffee machine in your tank if you could? Oh yeah, no, not a machine, a coffee dispenser. Be on tap like all the time. So yeah, I guess I can understand that. What's the delta V of a T-72 turret popping off? Well, and Ennis, if we were going to do the math, we'd have to take the total impulse of the shell. So, you know, how many shells did the T-72 have at the time when it exploded? So how much ammo was on the rack? And you'd have to take the energy of each shell, right? So you'd have to figure out the characteristic energy first. And if you figure out, well, not characteristic energy, the total impulse would probably be what you want. And then you would have to understand the exhaust gas velocity of one of those shells exploding. If you got your exhaust gas velocity of the turret popping off and the total impulse of energy from all the shells going off at the same time, and then take the mass of the turret, figure in some gravity into there, you should be able to figure out the delta V of the turret exploding. Yeah, and flying up into the air. That is calculatable, absolutely. What the hard part would be to figure out the coefficient of drag of the turret on the way up, because there would be drag, absolutely. It's flying. There's drag. Yeah, that's absolutely doable. You need to figure out the total impulse of the shells first. And then what is the exhaust gas velocity when the shell explodes? And then, yeah, you could figure that imparted force on the turret. Yeah, you can figure that out. That shouldn't be too hard. Opinion on the Sheridan. Floating, I like what they were trying to do with the Sheridan. Good idea. The problem is the Sheridan gets a bad rap because the Sheridan doesn't work very well in the jungle. Well, I suppose it works decent enough, but... So the Sheridan tank, guys, was basically, it was an aluminum tank. They made the tank out of aluminum. Its armor was all aluminum plating, so it could be moved around very quickly, and you could, like, fly it in. You could drop a Sheridan out of the back of a C-130, and they used them pretty extensively in Vietnam, and it has a 155 on it, if I'm remembering right. 155 mil turret on it. The problem is... And Sheridans are also amphibious, if I'm remembering right. The Sheridan tanks are one of those things that seem like a really, really smart idea on paper, but in reality, yeah. Yeah, making a tank out of aluminum was not the best idea. Yeah, aluminum doesn't make good armor. Not a good idea. Anyway, space news. Let's roll. Whoop! So check this out. This is coming from a company that's been around for a little while called Vast. Vast announced the Haven 1 and Vast 1 missions. Okay? Here, I'll show you this video. Interesting, Signer. Capture confirmed. So the Haven 1 mission is a space station module, a commercial space station module, and Vast 1 is a crewed mission on Dragon to fly to said space station. The space station module will launch in 2025, and the mission will be subsequently behind it. This is a commercial space station endeavor. And yeah, pretty freaking cool, man. Like, I don't... This is showing the emerging commercial low Earth orbit economy here, which is actually really cool. So 2028. No, I disagree, Hellfish. I think when they say 2025, I'd say maybe 2026 at best. I don't think 2028. You know why? The most complicated part of this entire thing right here is already flying. That part. That's the most complicated part. This is not complicated compared to that. Don't get me wrong. This is still complicated. But the interesting thing here is that I've noticed there's a lot of interesting pieces on this space station module. Take a look. I'm surprised they didn't go for a dry workshop starship. And it will all lead to bigger stations from Vast, which will be launched by Starship. Well, there you go, Tessa. I've been wondering when a third party was going to build something to top a Falcon 9 like Dragon. So, okay, that cupola module looks exactly like the one that flew on Inspiration 4. Just putting it out there. A lot of this stuff seems like it's derived from off-the-shelf components. But I could be wrong. Those look like Dragon 1 solar panels. Just putting it out there. That right there is definitely a docking, an IDA. That's NASA's NDS. So this is off-the-shelf stuff. It's off-the-shelf stuff at this point, and if you notice, there's a payload attachment fitting. The PAF is going to be cylindric right there, and the second stage would be right here in this design. These look like Dragon solar panels to me. So it looks like Vast is collabing with SpaceX pretty hard here to make this space station module. It looks like there's a lot of Dragon 1 components that found their way into this design. And I'm willing to bet dollars to donuts that those are probably Draco thrusters. So I see a lot of NASA and SpaceX stuff incorporated into this module. Now, here's the other thing to consider here, I suppose. That looks like this Vast spacecraft here, this spacecraft space station module, it's clearly got power and propulsion already on it, right? That looks a lot like Dragon XL. Or thrusters from the launcher orbiter, since Vast does own launcher. Yeah. That looks a lot like Dragon XL. Is this a single-use station? If not, how are they going to resupply it? Well, you can resupply it with Dragon. This will launch on a Falcon 9. Scale's wrong for that being an off-the-shelf window. The Dragon cupola is the size of the docking port. It's not, though. It's a little bit bigger. It's the docking port and its surrounding stuff. Aqualux. Yeah, it's a little bit bigger than the docking port, dude. I know what you're saying. I think you're missing the scale just a little bit. The cupola is the cupola that flew on Inspiration 4 is not the inside ring of the docking port. It's the outside ring. That one might be a little bit bigger, but I'm pretty sure that that's the same size. It might. Yeah, I see what you're saying. It could be a little bit bigger. They need an option to dock an alternative craft. One of anything in space scares me. Hotel, this is blatantly using NASA's NDS, so NASA docking standards, or the international docking standards. That's blatantly an IDSS port. Starliner could dock to this thing. Dream Chaser could dock to this thing too. See, when they put the cupola module on here, the cupola started at the docking, where the docking hooks are. See what I'm saying? It's a lot bigger. It's not the inner ring, it's the outer ring. Oh yeah, in this render I see what you're saying. It does look a little bit bigger. I mean, if there's an issue with it or something's already docked. Oh yeah, secondary docking port. Yeah. Perhaps having 2 docking ports would probably be better. Nice render. So, yeah, this is what's going on here. Once again, the last thing that I want to say, like, this looks a lot like the Dragon XL proposal for Gateway Logistics Services. Yeah, the docking animation is great. There's a CBM behind this. Let me look at the render again. Yeah, it's hard to say. Yeah, maybe. I can see this just being the first part. Yeah, perhaps. But either way, this is they announced a commercial endeavor here, which is pretty cool. And once again, the most complicated part of this entire project already flies, so that's actually pretty cool. Tell me, if you were building that, why would there not be a CBM on there? I don't know. I mean, I would have designed this with a docking port front and back and put the windows on the side. But that's just me. Another interesting thing is that the thrusters are on the same side as the docking port, so does Dragon, if this thing wants to boost with Dragon attached, do these thrusters just, I mean, yeah, they are kind of pointed out, so I suppose that does make sense. Note that it has orbital maneuvering and control thrusters, so like it has an ohms thruster, and then it also has RCS. These thrusters are for boosting, for sure. This is why I'm like, I'm looking at this and I'm wondering if SpaceX farmed out the Dragon XL proposal. And the second part of this is that if this thing launched on Falcon Heavy with an extended payload fairing, could it get to a rectilinear halo orbit with these thruster modules on board? Because like I said, this does look like gateway logistics services. And if you put a CBM on the front of this, for instance, it could dock to gateway. It could dock anywhere. Side windows would compromise the wall. Design challenge. I suppose. It works on airplanes pretty well. Yeah, both of these are going to launch on Falcon 9, interestingly enough. But yeah, that's VAST, and the VAST 1 and the Haven 1 mission. Pretty cool. Airplanes don't fly in space. Yeah, I know. What's the space shuttle then? That not an airplane? The space shuttle doesn't even have circular windows. They're kind of circular, more or less. They're like a beveled square. It's a glider. Dude, I saw, Novus, there was some guy on Twitter that just wanted to be right. And I didn't read the thread too hard, but the guy was arguing with people over whether the shuttle is an airplane or not. And or whether it was called a space plane. He's like, it's not a space plane, it's a glider. And everyone's like, no, it's a space plane. And he's like, no, it's a glider. It's a glider. It's called a glider. It's a glider. It's not a glider. It's not a space plane. And, dude, that whole thread, I'm just like... I noped out of that thread. It was just a thread on Twitter about people, space Twitter, arguing about semantics. And... oh, okay. Like I said, it's a zoo. Enjoy the exhibits. Don't become one. It was pretty funny, actually. Occupy Mars. Yeah, people keep linking me to this. Occupy Mars just entered early access. Oh boy. What is this? So yeah, that's the VAST 1 thing. That's actually some pretty awesome news there. Alright. What do we got? No, I just watched Waffle play it. It's bad. Fill me in, Frog. What do you mean? Huh. Okay, 3D, but it's super early, practically unplayable with just a bunch of SpaceX IP and Boston Dynamics stuff thrown in for interest. Cranes. I see what you mean. Hey, they did helicopter on Mars! Nice. No. 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 Huh. Interesting. Stick to stationeers. Yeah. I love how fantasy depictions of space habitats always grossly give so much volume and space to them. I'm just wondering why the launch site is so close to the freaking base. You know that this thing would launch, like, it would... Starship? Yeah. Do you want that near your base? Your pressurized base? Excuse me. Then you'd have a Martian-style dust storm. Yeah. Yeah. Interesting. And the dome would be full of concrete. Yep. Waffle just gave up on it. But his foot is in the plume. That's the foot. His foot is in the plume of the rocket engine. All right. That's kind of cool. His foot is part of the human arrow foot spike nozzle. Yeah. Yeah. Screw this garbage game, just no. Don't judge a book by its cover, buddy. You know, I think we'll let it... We'll sit on that for a little bit. Rocket Lab selected to launch a small sat swarm for NASA. Rocket Lab, a global leader in launch service and space systems, today announced it has signed a deal to launch NASA's Starling mission, a multi-CubeSat mission to test and demonstrate autonomous swarm technologies as well as automated space traffic management. Cool. Neat. The four Starling with a G at the end, not Starlink. Starling small sats have been manifested on an Electron commercial rideshare mission scheduled for liftoff from Complex 1 in New Zealand in Q3 of this year. Rocket Lab will deliver the satellites to space within 3 months of the contract signing. The Starling mission is designed to test technologies to enable future swarm missions. Spacecraft swarms refer to multiple spacecraft autonomously coordinating their activities to achieve certain goals. Starling will explore technologies for in-space network communications, onboard relative navigation between spacecraft, autonomous maneuver planning and execution, and distributed science autonomy. Interesting. Star Bing Chillingling. Starling was originally going to launch on Firefly rockets with nanoracks providing integration services. They pulled the plug on that. Ooh. Interesting. Interdasting. A Slossian epic for space news. How do you feel about Lop G? Wow, thank you, man. I haven't heard anybody call it Lop G in a long time. You're talking about Gateway? You know, dang, I mean, Robert Zubrin, one of the founding members of Mars Society, has called Gateway a toll booth in space, basically slowing us down. But I agree with him. I think it's a toll booth. I think it's not really the best way to go and explore the moon. However, if we look to history and figure out, ideally, what would be the best way to go and explore the moon? Well, there's only been one successful way of exploring the moon that we've done in the past. That successful way was the Apollo program. Landed 6 times on the moon between 1969 and 1972. 6 times. I would say that is probably the best way to get to the lunar surface and explore around the moon. The thing about that is that apparently the Apollo program wasn't very sustainable. I would argue that there are other reasons why the Apollo program wasn't sustainable, namely stagnation of governments basically wanting to go to the moon. Soviets pulled out, basically stopped doing their lunar program when they got wind of the U.S. defunding NASA. When the shuttle came around, the Soviets said, "Man, you're not going to the moon anymore. I'm not going to the moon anymore. Whatever." I would say that it has much more to do with stagnation of demand in the industry. It just, But either way, I would say that that's probably the most the quickest way, no toll booth, to go and explore the moon. Now, to safeguard against that, Gateway is there as basically a sustainable point around the moon that we can use for beyond low Earth orbit exploration and scientific research. So, in this regard, it's actually not too bad, because once Gateway gets up and running, it'll basically give us an excuse to not pull the plug on the program, which is what it basically means. It's more sustainable. You know, you pay if there's a toll booth on a road, that toll booth is there to help basically cover the costs of maintaining said road. Gateway is a highway that basically goes to or SLS and Orion is basically a highway that gets you to lunar orbit, and Gateway is the toll booth to get you down to the lunar surface more sustainably. So, has there been more comprehensive architectures in the past? Yeah, absolutely. Sure. Saturn V is arguably more comprehensive than SLS and Orion at this point. However, I would say that SLS and Orion with Gateway is way more sustainable. That basically gives you the political capital to keep that program going for a very long time. I would also say that Robert Zubrin, when he said Gateway was a toll booth, was talking about it in a bad regard. It's a toll booth. It's a waste of time. And in that regard, I think he is right. But I don't think. I think not factoring in the political capital there, that, it's a nice sustainable thing, Gateway makes a great prototype Mars transfer vehicle too. They're taking the ISS International Treaty Commitment playbook to keep us locked in through leadership changes. Yep, much more sustainable. But see, T-minus 5 minutes till the Stennis test. Yeah, that's the big thing, Novus. Gateway is in a position where you only need a heavy rocket to get to it for resupply, and you don't need a super heavy rocket to get to it. That's a big difference. We're talking about a couple of extra kilometers a second here of delta V. But an interesting thing to kind of point out, and I think this is important to mention, is that the Saturn V could do Gateway. Saturn V could build a Gateway. It could. Saturn V could do it. Which goes back to kind of what I was saying. In the past we said that Apollo wasn't very sustainable. And they cited that, it's just flags and footprints. There's no scientific research being done. And that's snake oil. That's absolutely wrong. Yeah. Absolutely wrong. The truth is that Apollo had tons of scientific missions planned. They pulled the plug before they did them. So, I mean, take that for what it's worth. So, once again, I don't think, Dank, it's very easy to say, oh, SLS is stupid. SLS, a Gateway's a waste of time. Gateway's just a toll booth. It's very easy to say that. A lot of people make this mistake. It's very easy to say that. But here's the thing, man. It's very easy to say that because you don't know what it was like when we didn't have any of this. All right? I grew up in the shuttle era. All right? Even having something that could remotely get near the moon with people on board was literally a pipe dream. SLS is not the most comprehensive design that we've ever made. It could scale into a very comprehensive and very capable lunar exploration vehicle and scientific exploration vehicle. Abso-freaking-lutely. Right? However, it's not the best right now, but it's better than nothing. Would you rather have nothing? Because we almost had that. We almost had nothing. We almost had nothing. In 2011, they wanted to pull the rug out on the entire program and just say, oh, commercial will pick up the slack. Yeah, we almost had nothing. So I'll take it. Gateway is probably not the most comprehensive architecture, but it's good enough. It's good enough, and we're almost done. We're almost there. And SLS and Orion and Gateway could scale into something very useful in the future. So I can't help but think that, you know, we could do something better. Like the Saturn V could do everything the Gateway does and then more. It's a more capable design because of its high energy stages, right? High energy upper stage like the S4B. However, perfect is, or better is the enemy of good in this regard, especially when it comes to lunar exploration. All right. The engine just started. So, where are more pros and cons for Gateway? Scary. Dude, we could have something like the thing is, and I agree with you. The thing is dude, we could have, they could just build another Saturn V right now. And somebody would be saying, oh, well, it's not good enough. Saturn V isn't good enough for Mars exploration. Perfect is the enemy of good. Good enough. Good. SLS and Gateway and Orion are good enough for what we need right now. And SLS can scale into something way better. Case in point, watch how long this engine fires for. This is a 630-second test of an RS-25. 630 seconds. That's absurd. That is an absurd amount of time for a rocket engine of this power and this capability to be firing for. How old is this engine? I'm pretty sure this engine's brand new, Foz. Oh, hello. This is a newer version, guys. This is an RS-25E. It is a... So, you know how people go back and they say, oh, well, why don't we just remake the Saturn V? Why don't we just remake the Saturn V? We could remake the Saturn V engine so much better with modern manufacture. That's a shuttle engine made with modern manufacturing. Yeah. Yeah, that's that, but with shuttle motors. So watch what this engine can do. It's pretty nuts, dude. Okay. She's throttled up where that shock cone is. Throttling up. $174 in. Everything's looking good. I thought this was the Phantom Express test for a second. You should also consider that a modern architecture needs to be open to collaboration with partners, private and international. Apollo didn't need to do that because no one else could. And I agree. And the interesting thing, Novus, is that, you know, 200 seconds in. The interesting thing is that, dude, you know, they called Apollo, oh, it's not sustainable. It's not sustainable. I think it's not sustainable because there was nobody around to make it work. It was just government versus government space program, and when one person pulled out, there's no need to do it anymore. It stagnated the industry completely, right? Nowadays, we don't have to do that. Dude, even if NASA had a Saturn V right now, I think if we just said rebuild Apollo right now and built it, it would be way more sustainable because there's a commercial market to back it up. Just a thought. Nice, Cooper. That's exactly it, Aqualex. It's politically sustainable, and that's okay. That's fine. I don't have a problem with that. You know, Aqualex, there's some so-called space fans out there that hate SLS because it is a Rule 8. It's Rule 8, a rule, you know, Rule 8 is the only reason it exists. Yeah, well, Rule 8 is the only reason why a B-17 exists, too, but I don't see anybody complaining about those things. They come in handy. They perform pretty good. Atlas 5 is another good example. Delta 4 is another good example. A Boeing 707 exists because the government pushed for long-range transportation of mail in the early 30s. Public-private partnership right there. And that, you know, those Clipper programs ended up becoming bomber programs that helped us tremendously in World War II. Just saying. You know, having a program like SLS and Orion gives you a concrete backbone to the industry that makes the industry a lot more sustainable. Saturn V couldn't be built today. It would have to be a scratch design because of how the original was built in the first place. All those machinists and technicians aren't exactly around anymore. It absolutely could be built today. Health issue would just take time. That's what you mean, right? It would take time. We can't just manufacture one because a lot of it was hand tooled, which is fine. That's okay. But it would be crazy to think that we couldn't manufacture one better today. Yes. All right, great burn here from this motor. The internet is just sent to the government. That's what I mean, Raven Garden. Yeah. So right next to the nozzle, there would be local pressure or local vacuum. It's vacuum. The engine accelerates the gases so fast into the flame trench it actually sucks other gases down. The pressure displacement. Yeah, there's a vacuum in there right now. It would feel like you're inside of a wind tunnel if the sound and heat from the rocket motor didn't kill you instantly. Yeah, it's actually just a big Venturi, dude. Yeah, see how the gases right there are being sucked down? It's a vacuum in there. You'd feel like a pretty windy day. Yeah, Linux, we could do it, but yeah, that's more the thing. It's the reason why Ford just doesn't make another Mustang, like a first-gen Mustang. Why? Why would you do that? Other than a nostalgia trip. Just why? And I'll be honest with you guys. Personally, I think SLS will scale into an architecture that'll end up being better than the Saturn V. Yeah, people don't like hearing that. Yeah, Aqualex, I think it's ridiculous. I think it's ridiculous. Yeah, no, I know. I think that SLS with the EUS in the Block 1B configuration, and then so the Orion Universal Stage Adapter, right, with the EUS, it'll be able to do 40 tons TLI. That's perfectly on par with Saturn V. And you have an EUS, which is way more delta V. A little bit more of a lower energy transfer. They throttle down the engine. And if you throw BOLE boosters into there, you throw carbon composite SRBs into that, now we're talking. That's a beast motor to do. Yeah, exactly, Tomas. SLS is fine. It'll scale into a really good architecture. I just hate that we made Block 1B first. I really don't like that. Deep throttling the motor. Well, not deep throttle. They're throttling it down. And an 8.4 fairing for cargo. I'm in, dude. I'm in. And then Block 1B variants in the future. You give that a 10-meter fairing. Oh. Maybe. No. Should we reuse the BOLE boosters? The carbon composite cases are not designed to be reused, I think. Hey Razzie, any news from Starship? They're still working on the OLM, dude. SLS with a 10-meter fairing? If you put a composite EUS into it, Hellfish, screw building gateway. Just launch gateway in one shot on top of SLS. Saying. Flame out at 629.9. Nice. So, that's a long freaking burn, dude.
Concludes the live broadcast of today's RS-25 engine test on the Fred Hayes test stand at NASA's Stennis Space Center. Please check the NASA Stennis website and social media channels.
You know, I say this out of love. They really, really know how to make these really boring. Like, you know, they could have a presenter out there with a crew saying what engine it is, what they're trying to do with the burn, interviewing the technicians, why they're burning to 630 seconds, what serial number this engine is. Like, you could do all that and people would be into it. People would be into it. You know, this, you know, do a little historical segment on the test stand. Now, they kind of did at the beginning, but they were just like, oh, this is on the Fred Hayes test stand. You know, yeah, I suppose they kind of did do that at the beginning, but. How much can Saturn V get to planets like Jupiter or Saturn? I don't know. I mean, Jupiter or Saturn, if I had to guess, this is a big guess, like 5 tons, maybe? They have a pre-recorded interview before the test. Does the SLS core have engine out capability after booster separation? Yes. That's why it has 4 engines. Like, dude, we could go out there and do a test. Like, oh, they're testing it now, like stuff like that. Man, it'd be so much nicer. The OG Voyagers for Saturn V. Oh, so the original design were 11 tons. Well, Vulcan, I suppose that goes back to Nova's question. Are we talking about a flyby here, or are we talking about capturing? Because the Saturn V could make something that could capture Jupiter, no problem. Proof of people being interested is 1.7 people watching. NSF live stream of Starbase watching some dudes a mile work away on stuff you can't even see. Yeah, there you go. Something like Europa Clipper, yeah. Or Cassini. The EUS would have more Delta V. Yeah, the EUS would be able to shoot it further. So, the Saturn V is great for human exploration. That's what it's really good for. That's what it was designed to do. It's good for sending humans places. SLS is okay at sending humans to different places. It's pretty damn good at it for a super heavy launch vehicle. But it also is very good at, it's being marketed to be able to do scientific payloads as well. What would your opinion on a NASA mission where they send crew out to interstellar aimlessly into deep space with the crew willingly knowing they won't come back? That's not space exploration. That's being a lemming. We don't do that. Sorry, I'm just looking at all these pictures of F-104s. What's going on down here? What's that about? Okay. That's, oh. Oh, yeah. Oh. Yeah, zero-length launch. So basically, rocket-launched airplane. Yeah. Yeah, that's pretty neat. I'll bet you they got the idea for this from early cruise missiles. Early cruise missiles like Regulus were launched this way. I can't decide whether this would be really, really cool to be inside the plane when it goes or really, really scary. Probably mix. Do they still do this? No. No. They do not. Anywho, that was the Stennis test, guys. I do have a NASA Spaceflight Phil Sloss article here. Let's see. You know, we were talking about SLS, so we might as well talk about Artemis 2. Artemis 2 is the first human mission out to the moon since 1972. It should be going sometime next year, probably late next year. But let's read. The first crewed Artemis mission is now the focus of NASA's Beyond Earth Orbit human spaceflight programs. Mission training for the recently named crew for the Artemis 2 test flight is expected to begin in June, just about the time that the mission integration review will be conducted. The space agency has been planning for lunar flyby missions for years, back to its origins in the last decade when it was called Exploration Mission 2. The Exploration Ground Systems, Orion, and Space Launch System programs are factoring in data and their experiences from the Artemis 1 mission that was completed at the end of last year as preparations for the spacecraft, launch vehicle, and ground launch infrastructure continue toward a launch no earlier than the end of 2024. First week of June, we'll have a mission integration review. That's a big enterprise level review on where are we with respect to planning for the mission. Where are we on our requirements, our launch commitment criteria? Where we are on the recovery decision criteria, on the flight rules, and we're transitioning from kind of a mission design phase to a mission prep phase. Mission integration review, yep. Artemis 2 will be the second launch of an SLS Block 1B rocket, which will send Orion and crew into a couple of very high Earth orbits. Yeah, that right there, guys, is the reason why that Stennis test, they're doing long duration burns, because SLS is designed to shoot stuff right into medium Earth orbit, which is actually really cool. Ready for today's Falcon 9 launch from Vandy at 4 p.m. Yes, I am. Artemis 2 will be the second launch of the SLS Block 1 rocket, which will send Orion and crew into a couple of very high Earth orbits. The first high Earth orbit will take the spacecraft and crew out to a high point of 70,000 kilometers. Almost twice that of geosynchronous spacecraft. The apogee of the second high Earth orbit will go all the way to the moon, making a single flyby before returning to the Earth for re-entry, descent, and splashdown in the Pacific Ocean approximately 10 days after liftoff. Interesting, RJ. I'll check that out later. We've kind of locked the mission down. You're trying to hone in on what the mission solution really looks like, and we're to the point now where we can kind of draw a line in the sand. We can kind of draw a line in the sand and say, here are the mission requirements, and we're going to start prepping all of these products that we're going to need for Artemis 2. So it's the mission prep phase. Really, the mission integration review is the point of demarcation between the mission design and mission prep. Okay, so basically they have the idea what they want to do all figured out. See, check this out. SLS is going to do a direct insertion at with a 70,000 kilometer apogee, which is all right. Actually, no, it looks like a MEO insertion, and then the ICPS will boost out there, and then it'll boost again, which is no. Oh, hold on. Let me see this. Okay, SLS does its MEO thing, like it did with Artemis 1. And then they fire the ICPS. Artemis 1, when it fired the ICPS there, translunar, went all the way out here. Artemis 2 looks to be firing this to high Earth orbit at 70,000 kilometers, they said. And then it'll separate, and then Orion will use its service propulsion system to finish up the rest. ESM puts it in TLI. This will be the farthest out from Earth we've been since the Hubble repair missions. Yeah, this is going way higher than that, Mayor. Yeah, crazy. The only humans that have gone further than this are the 7 mission, so 8, 10, 11, 12, 13, 14, 15, 16, 17. The 9 Apollo missions. So only 27 people in human history are going to go further than the Artemis 2 crew. Check the proximity operations demos. Orion separation from interim propulsion stage followed by proximity operations demo, plus manual handling qualities assessment for up to 2 hours. What, are they going to redock to the dang thing? How high is Polaris going? Polaris Dawn is basically going where 5 is. A little bit less than that. Oh, right border. Yeah, it's over there. So separate, turn the capsule around. Interesting. All right, Linux, see you, buddy. Yeah, they're basically going to turn around, move around relative, and then circle around 90 degrees relative to the stage, and then maneuver around again. So no docking, no redocking with the stage. But they're using it as a datum for proximity operations. Smart. Cool. I think this basically just covered everything that we just said. The SLS Block 1 vehicle can send Orion to the moon in an approximately 2-week-long alternating periods, about 2 weeks of launch I gotta read that again. The SLS Block 1 vehicle can send Orion to the moon in approximately 2-week-long alternating periods. About 2 weeks of launch opportunities would be followed by 2 weeks without opportunities. Following the successful Artemis 1 uncrewed test flight, NASA will have some additional flexibility to go along with the experience and learning gained from the first SLS launch and a second recovery of the Orion crew module. I agree, RJ. It'll be really good. Unlike Artemis 1, Artemis 2 will not have any daylight constraints. Artemis 1 launched at night, but was required to splash down during daylight. For Artemis 2, neither launch nor landing and recovery are required during daylight. A daylight launch is not a requirement, and we removed the recovery requirement having to be in daylight. That was a requirement for Artemis 1, but not moving forward. NASA will also bring a second large liquid hydrogen storage sphere online at 39B, beginning with Artemis 2. Construction of the sphere was completed before Artemis 1, but integrating the additional storage capability into the ground launch system was always planned for between the first and second SLS launches. The additional LH2 capacity will give the Exploration Ground Services launch team more opportunities to make SLS launch attempts within a set period of time. On Artemis 1, we had no more than 3 attempts in 7 days, and you had to have 48 hours between attempts 1 and 2, then 72 hours between attempts 2 and 3. For Artemis 2, we have the ability to make 4 attempts in 6 days, and there's a 24-hour turnaround between attempts 1 and 2, and then a minimum of 48 hours between 2 and 3, and between attempts 3 and 4. So if we scrubbed on day 1, we could turn around the next day. We have about 1.4 million gallon capacity in the new liquid hydrogen sphere. That really helps. So that really helps launch attempts. Yeah, they had to store excess hydrogen at Slick 37, Delta 4's launch pad, and that's why SLS turnaround was really, really slow, because they didn't have enough hydrogen on site to refill SLS in case there was a scrub. Fuel is stored in the balls. That's right. Yes. Heading into the Artemis 2 campaign, with vehicle integration stacking currently planned to begin next year in 2024, and other constraints and some limit operational life items that came up during Artemis 1 campaign may also be factors in shaping launch availability. Above and beyond the celestial mechanics, the flight termination system has time constraints on its operational life. Currently, that will have the same 25-day maximum that it had for Artemis 1. We'll be using the same concept of operations that we started with for Artemis 1. Likewise for things like stack life of the solid rocket booster motor segments, which have a generic 12-month constraint. Ramsey said there are no changes to the constraints. NASA is not planning on SRB stacking for over 12 months for Artemis 2. But as with Artemis 1, they will do extended life analysis for flight-specific waivers if necessary. Newell, hey, 6-month reset. Wow, time and a half already. Yep, there's the new hydrogen tank that they built right there. That was the existing one. That's the new one. Cool. On launch day, boarding the crew on Orion at the launch pad will be new to the countdown. The length of time the crew can be lying on their seats in the crew module will also be a new launch day constraint. Going in, the plan is for the crew to begin getting into their seats 3 hours and 15 minutes before the opening of the launch window, which can be as long as 2 hours. The technical performance metric that we're shooting for is 3 hours and 15 minutes. The requirement is we can't have the astronauts on their backs for more than 5 hours and 15 minutes, so 3 hours prior, 2 hour launch window. Once both of SLS's liquid propellant stages, the core stage and the ICPS, are fully loaded with liquid hydrogen and liquid oxygen and are in stable replenish, the crew will be allowed to go to the pad to board Orion. Yeah, don't board crew during fueling operations. It's either before fueling operations or after, not during. During is very dangerous because when you're tanking a rocket, when you're filling it up with fuel, you're changing a lot of things on the rocket really, really quickly. Changing the total mass of the vehicle, changing the temperatures of the vehicle, pressures are changing. There's a lot of transients going on, so you don't fuel while people are boarding. That's a good way to get people hurt. Once we get into stable replenish for the liquid oxygen and hydrogen, then we start loading the crew, and the clock starts when the first crew member is on their back. Then you load the rest of the crew members. That 3 hours and 15 minutes is targeted when you load the first crew member, and there are multiple reasons why that requirement is a total of 5 hours and 15 minutes. That's why SpaceX fuels Falcon 9 after the crew is on board. That's correct. But SpaceX has to arm their launch escape system to do fueling operations, Nova. Section 6 of launch operations for Crew Dragon. Yep. Well, I got 1 year of college under my belt. I moved out yesterday. Congratulations, RJ. There you go. Good job, man. Nodders. Nodders. Prior to its renaming, Artemis II was called Exploration Mission 2. Although the mission was always planned as the first group flight test, the concept and planning for the mission went through a few changes in the last decade. It was moved to the still being developed SLS Block 1B vehicle when the exploration upper stage officially started in 2016. Then EM2 was moved back to the Block 1 vehicle in 2018 after Congress started funding a second SLS mobile launcher. By the end of 2018, the mission was rebaselined with a few notable changes from what was EM1 at the time, soon to be branded Artemis 1. That mission plan included a different sequence of events after core stage main engine cutoff and separation, with a short burn of the SLS ICPS occurring a few minutes later before Orion deployed its 4 solar array wings. A high Earth orbit has long been planned for the mission, but in 2018, the high point, or apogee, was significantly raised up over 100,000 kilometers for an orbital period of 42 hours. Shortly after that 2018 baseline update, NASA's lunar plans and strategy changed. In March 2019, the Trump administration made a crew lunar landing no later than the end of 2024 as the agency's top goal, and NASA subsequently began looking at the rebranding Artemis Manifest and ways to reduce risk of the lunar landing schedule. For Artemis II, NASA evaluated moving up rendezvous, proximity operations, and docking capabilities planned for the Orions on subsequent flights, and eventually decided later that year on a narrower scope proximity operations demonstration hand-flown by the crew. The current mission plan includes that and the other changes to that pre-Artemis baseline. The SLS core stage and boosters will insert Orion into an initial orbit with an apogee of 2,200 kilometers and a suborbital perigee of 28. Holy balls. No wonder they need a 600-second burn time. Wow. That's insane. That's really, really impressive. The post-main engine cutoff sequence of events now follow the one seen for Artemis 1. With Orion solar arrays deployed first, the ICPS perigee raise maneuver performed at about 50 minutes after liftoff to raise the perigee up to 185 kilometers. About an hour later, around 1 hour 50 minutes after liftoff, the ICPS will make a long apogee raise burn. The apogee raise burn raises apogee to approximately 74,000 kilometers and decreases perigee to 0, yielding an orbital period of about 24 hours rather than the 42-hour-long orbit previously planned. Even though the perigee of the high Earth orbit is suborbital, the vehicle won't reach that part of the orbit for almost 24 hours. In the meantime, Orion will separate from the ICPS and the crew will begin proximity operations demonstration. It's not an automated demonstration. We have the docking camera that the crew will use. The intent there is to separate from the interim cryogenic propulsion stage and to establish some rough and fine handling qualities. The commander and the pilot will be doing these maneuvers with the onboard hand controls. Orion separates from the ICPS. It translates about 300 feet, about 100 meters, and then it turns around and looks back at the ICPS. Then it approaches Then it approaches the stage. Orion is responsible for all that. It approaches into about 30 feet, 10 meters, and then backs off and does the same course handling approaches to the ICPS again, and this is head on. It's coming back and looking at the top of the Orion stage adapter, where the docking target is. Then it backs away. The ICPS does a maneuver, and the Orion comes up to the side of it and does the same type of maneuvers. That docking target is located on one of the X braces of the ICPS. Then it starts to back away, and it continues to back away until it leaves the ICPS's area. So basically, if this is Orion, right? If this is Orion and this is the ICPS, it's going to separate. It's going to go out here. It's going to turn around, come back, back off. They'll turn the stage. It'll go forward again, back off, and then fly away. There's got to be some pretty good views of that, Thomas. Yeah, absolutely. Like what they did for Apollo. That part, the RPOD stuff for stage Nova will be like Apollo 7. Apollo 7 did that, if I'm remembering right. This mission is like a combination of, it's a combination of Apollo 7 and Apollo 8. Like rolling it all into one mission. That maneuver is how I ended up with 2 kids. Okay. Don't ask detailed questions. I didn't! Didn't ask you any questions. Okay. Yep. Orion will perform an upper stage separation burn about 5 hours after liftoff to put further distance with the ICPS, and the ICPS will perform a disposal maneuver at about the same time to change its perigee to minus 37 kilometers. Yeah, so it's going to burn up. The ICPS has batteries, and it doesn't have solar arrays, so it's got to operate within the constraints of the batteries. It's spinning up and deploying secondary payloads, and then it's spinning back down. Yeah, the Delta Cryogenic Second Stage, which is basically SLS Block 1's upper stage, the ICPS, has RCS on it. It can maneuver around. Halfway through the orbit, about 13 hours after liftoff, Orion will perform a perigee raise burn to once again raise the low point of the orbit back to 185 kilometers. Assuming all new craft and life support systems on Orion are operating well and everyone is go, approximately 25 hours after liftoff, Orion will fire its main engine to perform translunar injection, sending the spacecraft and crew around the moon in a free return flyby trajectory. I'm going to be pissed if we get the same ITAR debacle that we did with Artemis 1. NASA needs to be a lot more forthcoming with its media. Sure, RJ. Interesting reference, but yes. This is a, you know what, dudes? This is a ballsy freaking mission. This is a ballsy mission. This is dangerous. That's why they're doing all these weird orbital insertions. So SLS, I talked about this a little bit earlier, but now I have the exact numbers. SLS will do a 2,200 kilometer apogee insertion. Basically suborbital, right? Then the ICPS will do a perigee raise maneuver and basically get the apogee up to 185, right? And then they'll float around again, right? And then the ICPS will put this thing into a 70,000 kilometer apogee suborbital trajectory, basically. So initially, you're suborbital at main engine cutoff, right? You're suborbital. And then they circularize. And then once they do the orbit insertion, get to step 8, they're suborbital again. The reason why they're doing this is in case something goes wrong, the capsule will basically always have a way to be able to get back down. Smart. Smart way to do it. That's why this mission is kind of hardcore, because some of these maneuvers are pretty intense. Not like intense like it's going to be intense on the body, but, you know, a 70,000 kilometer apogee is unreal. Yeah. Like I said, only the 9 Apollo missions that went out to the moon. Only 27 people have been higher than that. Excluding Snoop Dogg. It was a good reference. Be quiet. So, the reason why they're taking it suborbital after insertion, and then Orion circularizes, and then Orion goes out to the moon, is so they always have... They're abort contingencies, guys, just in case something goes wrong. That's tough. This is a hardcore mission, dude. The 4-person flight crew for Artemis 2 is expected to begin mission-specific training in June. Ramsey said that there is a backup crew planned for the mission, but decisions on that will be sometime in the future. The plan as far has been communicated. The plan that's been communicated to me is that we have a backup crew member to be. That sentence sucks. The plan as far has been communicated to me is to have a backup crew member to be named later. Now go build a replica in KSP2. Now go build a replica and run it in KSP2? Maybe we'll do that tomorrow. The crew will begin training around the same time that NASA holds the mission integration review. The review is planned around the launch minus 18 month or L-18 time frame, which corresponds to the net date in November and early December 2024. The proximity operations will be manual. Pretty. Novus, this has always been I think that's cool. I think that's cool that they're doing manual stuff. If you really want my honest opinion, I think that how am I going to put this? I've always advocated for an entire manual backup system for
Discovery, go at throttle up.
And even so far as analog gauges and mechanical backups for all systems on board spacecraft. Yeah, because, dude, when you're going out to the moon, you never know. Automated trajectories out there. Long story short, I want somebody to be able to fly the spacecraft manually, basically instantly. Now, don't get me wrong, you can do that with Dragon, but I also think that mechanical backups on board. So having a nice touchscreen, like basically how a plane's set up. A plane has primary flight displays, and you have a PFD, you have an MFD, and that's all digital controls, but planes do have redundant gauges on them and redundant mechanical switches. You still have a circuit breaker behind you. I think having those systems on board are very good. And honestly, future lunar operations, dude, I think should be flown by hand. There, I said it. Maybe not landing, but RPOD should do that by hand. I mean, there's the relative navigation. TRN should be able to fly by hand with a computer, right? But I actually like that Orion, for the RPOD is doing full manual control. I think that's a good call, because when you're going out to the moon, now people are going to be like, "Oh, Jay, what do you mean? Everything should be automated. It's better. The computer can do it faster." Now you're absolutely right. You're absolutely right. But the thing is, when you're going out to the moon and you're going to roll the dice like this, you're doing just that. You're rolling the dice. You never know when you're going to need to take manual control of something. In fact, I will contend to say that The ability to be able to take manual control of certain spacecraft during the Apollo program is literally why Neil Armstrong and Buzz Aldrin aren't paint on the surface of the moon. Yeah, you never know when the poop's going to hit the fan, and it will, eventually. And the best thing that you can do is have redundant systems in place like manual overrides to be able to take control of things. I honestly want that in my car. I love buttons. Me too. Do you think Starship crew will have a manual crew control? I think Starship should, Erudite, if you really want my honest opinion. The crew versions of Starship should have a flight deck like the Space Shuttle. Yep, there, I said it. Yeah, I think that Starship should have a flight deck like the Space Shuttle. Yeah. It'll never happen. I don't think they'll do that. But, you know, like, here's the thing. It's hard to... I don't know if somebody could fly that manually right there. That might be an issue. Trying to land a Starship by hand. It can be done. We did it in KSP. But you need to have very throttleable engines, and Raptors are pretty damn throttleable, and they respond to throttle. Their throttle response is pretty damn good for what it is. But I'm not sure it's good enough to the point where people can be like on board and controlling it, you know. But I do think Starship should have a flight deck and a manual control system. Just in case. I mean, what if the thing did what SN9 did? You know? SN9 screwed up its flip maneuver, right? And then the computer just shut the engines off and, okay, I guess I die now. You know? But I don't know. What do I know? Do you think Artemis 3 will happen before 2030? Yes. Mm-hmm. They'll probably need manual control for the lunar variant. Agreed. Mm-hmm. Yeah, I think every spacecraft should be like that, dude. I think they should be set up like airplanes with manual controls as a backup just in case. Because like I said, man, not everything is going to go exactly according to plan when we go back to the moon. This is the big leagues. You know, you'll see with this launch in a little bit. Now that I said something, I probably jinxed it. Just flying up on a low Earth orbit trajectory is meh. Heck, even flying crews to the ISS, you know. We did the Crew 6 coverage the other day, and it, you know, it wasn't nearly, like, it wasn't DM2, you know what I mean? Like, going to low Earth orbit, even with people with Dragon and Falcon 9 with Starlink satellites, etc., even a Falcon Heavy mission, those, like, it's becoming pretty dang routine. Like, we got that down pat pretty dang well. At least SpaceX does, right? So when we go back out to the moon, that's the big league. That's where it gets more difficult. The difficulty scales exponentially the further you get away from Earth. Wait, why do we need to go back to the moon? Sally, I honestly think, you know, there's not one particular reason. I think a big one. I think one of the biggest things that the space program does that isn't necessarily a quantifiable thing, but it's a point of national pride, dude. It serves to organize and measure the best of American skill set. It serves to organize and measure the best of our skills. I think the SpaceX is, no doubt. I think that NASA is a feather in the U.S.'s cap. It shows what we're capable of doing. And it's a point of national pride. Just like, I don't know, tea with England, you know? You think tea, you think, oh, England. You know, you think baguettes, you think France. You think bratwurst, you think Germany. You think spacecraft, us. I mean, you can't eat a spacecraft, and now I'm hungry, but you get what I'm trying to say. I think that's probably one of the most important ones, dude. Now, don't get me wrong, there's also a lot of science to gain. There's a lot of scientific understanding to gain. If we could figure out how to do sustainable resources on the moon, well, that's a big game changer. I think the point of national pride is something that's drastically overlooked. You know? I mean, it also serves, the moon is a pretty good training ground for going to Mars. It's harder to live on the moon than it is to Mars. Mars has more resources than the moon does, like an atmosphere with oxygen in it. Now, don't get me wrong, Mars's atmosphere doesn't have a lot of oxygen, and the oxygen that it does have is attached to a carbon molecule, so it has a lot of carbon dioxide. But that's usable. The moon has no oxygen, except in water caps on the North and South Pole, which is kind of why we're going. Part of the Artemis missions is to is to go and mine water or drill the ice caps on the moon. Well, there's not an ice cap. There's water in craters at the North and South Pole of the moon that we can use for, well, hydrogen, 2 hydrogen, 1 oxygen. If we could get a hold of that, we can use that to make rocket fuel. You can use that to make breathable air. You can use that to make water. Just drink it. That's kind of important. We need to do that. If we can figure out how to do that stuff and utilize it in situ resources, so stuff that's there already, man, maybe someday we can move manufacturing things to the moon. If you have hydrogen and oxygen, you can make electricity. You can make power. You can make anything you want with those two. And people can live off of those two for the most part. We still need food. That's a whole nother story, though. Those types of technologies are the types of technologies that will move us truly into, like, maybe an era down the road where we don't need to depend on this planet as much for resources. Yeah, exactly, Nova. The moon's right there. It's our backyard. You go camp. You'd go if you're not going to go camping in Yellowstone right off the bat, right out in a national park. You'd camp in your backyard first, and then go camping once you figure out what you're doing. Then go camping in Yellowstone. But I think national posture has a lot to do with it. I think that the space program is a feather in our cap. It's something that every single American can get behind, and it shows what we can do when we put our minds to it for a change. You know what I mean. They were talking that it would possibly be easier to start missions from the moon to the outer planets, right? Less interference, scientific instruments from Earth's atmosphere. Alice, that is a plus, but honestly, refueling at the moon and then going to Mars doesn't really make any sense. Like, you know what? I'm not going to say that it doesn't make any sense. It does, but that's like, if we figure out how to manufacture things on the moon, like build spaceships on the surface of the moon, then maybe, then it would make sense. Because it's, we could send raw materials to the moon and then build a gigantic freaking spaceship on the moon and then send that somewhere. That's not a bad idea. It only really makes sense if you build everything there, in situ resource utilization, which is a huge thing that's really important. He learned that from Kerbal. Moon is not a good refueling place. It's more learning it from physics, Willie, but yeah, Kerbal does teach that pretty dang well. Yeah, looks, there you go. Transfer windows are a bit more difficult from the moon. Exactly. Utopia Planitia is better than the moon. I understood that reference. The moon is also a really good place to mine all the things we need here on Earth. Yeah, I mean, but Aqualux doing that, if we're gonna do something like that, we have to have a viable transportation system, something basically where we can move stuff in bulk to and from the moon. Eventually. Yeah, there's also China. But, yeah. Alright. Let's see. Let's go back to this article. And Russia? Well, Russia ain't getting near the moon on their own anytime soon, Novoraptor. The target for Artemis II launch readiness is currently being driven by the schedule and progress of spacecraft and launch vehicle assembly. The Orion spacecraft for Artemis II is the first with full support for a crew of astronauts, and assembly and test of the crew and service modules is the primary critical. The Orion spacecraft for Artemis II is the first with full support for a crew of astronauts and assembly and test. The Orion spacecraft for Artemis II is the first with full support for a crew of astronauts, and assembly and test of the crew and service modules is the primary critical path. Give me 1 second.
Discovery, go at throttle up.
Non-Flake, 6-month resub. Hang on 1 second. Okay. Okay. Okay, that problem's getting addressed. What? I know people. What? Where was I? The last public update in early March projected that standalone integration and testing of the two modules would be completed by June, which is when the two would be mated for launch. When prime contractor Lockheed Martin completes overall integration and testing of Orion in the operations and checkout building at KSC, they will officially turn the spacecraft over to EGS for launch processing. The EGS timeline for Orion forecasts about 8 months from handover to launch readiness. If Artemis II is going to be ready to fly before the close of 2024, Orion will need to be ready for that handover next spring, about a year from now, F. The elements of the SLS launch vehicle for Artemis II are expected to be delivered to KSC before the end of the year, with the exception of the SRB aft skirts and forward assemblies that are processed at KSC. Integration and testing of the rest of the launch hardware occurs at facilities around the United States. The 10 solid propellant motor segments for Artemis II were completed along... The 10 solid motor... Frick it! We'll do it live! I can't read. I don't know what it's saying. We'll do it live! Frick it! Frickin' thing sucks! Anyway, sorry. I can't tell what you're doing. No, I'm just kidding. I'm not mad. It's a meme. It's a meme, you dip. Jeez. And we'll play it out here. We'll play it out. I don't know what that means. The 10 solid propellant motor segments for Artemis II were completed a long time ago and have been in storage in Utah. A long time ago. They are expected to be transported by rail from Northrop Grumman's Promontory facilities in the second half of 2023. United Launch Alliance assembled the ICPS for the mission at its Decatur, Alabama facility, and the stage was shipped to Florida in 2021. It is now undergoing final ULA preps before being handed over to Exploration Ground Systems. What is Promontory? Promontory is a town in Utah. It's northwest of Salt Lake City. If you've heard that name before and you like trains, Promontory Point is where the Golden Spike was driven. That was the first transcontinental railroad in the United States. Yeah, that Promontory. That's where they make SRB segments. They've been making SRB segments there since the 70s. Please make a now F Nightbot response to F's in chat. Nauf. Okay. The SLS interstage adapters, launch vehicle stage adapter, and the Orion stage adapter are also completed and are still in storage at Marshall Space Flight Center. They will also be transported to KSC this year. Leroy, of course I'm interested in OKGLI pictures. Duh. Yeah, of course. Okay, guys, am I just having trouble reading? Am I just having trouble reading aloud, or is the grammar in this a little... You know how to read? Apparently not. Like, am I... Dude, it's been a while. No, EJ, you're able to read just fine. It's been a while, but I don't think that's where you use that. This sentence here is... The SLS interstage adapters, the vehicle staging adapter, and the Orion stage adapter are also completed. And still in storage at Marshall Space Flight Center. They will also be transported to KSC later this year. The article was too long, so the editor just gave up. Fun fact, those boosters exist because a couple of nerds wanted to make better rain boots. Someone at JPL took notice of one of the polymers they were playing with and figured out it was a great binding agent for solid rocket fuel. All right. I don't think so, Willie. That's not what we're talking about. Thank you, Mr. Drummer. Here you go. Ooh. Leroy, let me finish the article, and we'll check this out. We'll check those pictures out in a moment. The major piece of SLS hardware still under construction is the core stage. The engine section bowtail assembly was mated to the rest of the stage in mid-March at the Michoud Assembly Facility in New Orleans. RS-25 engine installation, final outfitting, and integrated functional testing of the stage remain to be completed. It's getting hard. It's getting tough, man. But then again, it's possible that I'm just not having a good reading day. Also, we'll do it live. We'll do it live! Engine installation will begin in July. NASA spokesperson Karine Beckinger said in an email. Teams are working toward a late fall delivery date to Kennedy Space Center. Okay, okay, Leroy. Yep. The core stage might not be needed for stacking in Florida until mid-2024, though, so there is still margin in that schedule. Is that the end of the article? That's the end of... Yeah. Yeah, more shots. Yeah. Like, I don't mean to dump on whoever edited this, because it's, to be honest, it's probably one of my friends. It's probably somebody I know. But, whoa. Whoa. No, the information in here is great. The information's good. It's just hard to read it. It's really difficult. Like, and there's just a lot of semicolons in here that I don't think need to be there. But yeah, but the information was fantastic. Yeah, no, I sent a message out to I sent a message out to the appropriate parties. Oh. Yeah, no, that was really trying my patience there, that article. I was like, ugh, I can't read this. I don't know what it means. We'll do it live. Frick it. All the semicolons should be periods. Yeah, like, once again, dude, if anybody's an English major out there, can you just double check me on this? Like, Oh, Aqualix, don't you worry. It's already been done. Yeah. Okay, am I stupid, or is there no conclusion to this? There's no conclusion here. It just stops. The article just stops. Yeah, no, I'm that. Yeah, that's. Moving on. Anyway, Leroy, let's see these pictures. What do you got for me? What do you got for me? What do we got? Boop. Ooh, very nice. Yeah. Okay, GLI. Very nice. Huh. Balls. Nice car. Dude, it has a Mura underneath it. I never knew that. Dude, a Mura. Look at that. All right. I don't think that the final versions of Buran had this, Aqualex. I've never noticed that before. Where is this at? This is Technik Museum Speyer in Germany. Yeah. These are great pictures, by the way, Leroy. Very nice. Yeah, see, this is OKGLI. So, OKGLI in Russian is basically orbiting vehicle flight test article for the most part. That's basically what it means. So, OKGLI was the atmospheric flight test article for the Buran program. It actually flew. It did fly, but it flew in a similar way to Enterprise. But Enterprise didn't have jet engines on it. NASA let Enterprise go on top of NASA 905, and then it glided down to the runway from there to do approach and landing tests. OKGLI didn't have a plane that they could launch Buran off the back of because the Antonov 225 was not finished when they were trying to do atmospheric flight tests. So they literally just attached some jet engines to the side. Yeah. Speyer Museum is the best museum I've ever been to. A grown child toy box. Dude, you gotta go to the Smithsonian sometime. Yep. Yeah, see, not all of the control systems were implemented, but they did put a throttle quadrant in and, atmospheric flight control systems. This thing did fly. It flew around. There's footage of it flying. And then they put a fuel tank in the payload bay. Big old fuel tank. That's what that is. Actually, you know what? That might not be the fuel tank for jets. That might be a water tank to get it to fly correctly. That might be just a mass simulator. I'm not 100% sure. Whoa. Berlin Tempelhof, Lufthansa. What's this plane? JU-52. Cool. Yeah, it actually took off under its own power. That's right. Yep. What the heck? I'm not sure what these pressure vessels are for. This kind of looks like a developmental flight instrumentation controller. It's definitely avionics, whatever it is. I don't know exactly what it is though. This could be fuel cells. It's hard to say. I'd have to like sit there and look at it for a little while. Hello? Yeah, it's just serial numbers. So why is it in Germany now? OKGLI was bought by an Australian company after the Soviet Union folded, Rezel, and it spent some time down in Australia, and then Technic Museum Spire acquired it from an Australian company, and yeah, now it's here. They bought it because there were, after the Soviet Union collapsed, there was a lot of government property that just found its way to auction. Yeah. If the 747 wasn't built, what other aircraft that could carry the shuttle in today's world? C-5. C-5 could do it. The reason why the bulb is on the bottom is to get the front gear lower to get airflow under the shuttle so it could take off. Oh, they raised it. Yeah, I got you, Thomas. Yeah, I understand. That makes sense. I was wondering if the flight orbiters have it, but yeah, that's to get it to nose up when it takes off. Yeah, I understand. Cool. Also, Mura. Could a B-52 carry it? Maybe. I mean, payload-wise, yeah, it's possible. What is the silver car? Hold on. So it's a Mercedes. That looks to be a pre-war Mercedes, dude. I'm not sure exactly what it is. It's a Cabrio, 2-door, but I don't know what it is. Could a 777X carry a shuttle? Probably. It looks like a Goring car. Hermann Goering had a lot of weird stuff, dude. He was the head of the Luftwaffe. He was basically led the German Air Force. He had a lot of weird cars. Here, let's figure it out. So that is a Mercedes 500K. That's what it's called. Let's read. Mercedes-Benz 500K W29 is a grand touring car built by Mercedes-Benz between 1934 and 1936. First exhibited at the 1934 Berlin Motor Show. It carried the factory designation W29, distinguished from the 500 sedan by the K for compressor, German for supercharger. Only fitted to these performance cars. It succeeded the Mercedes-Benz 380, introduced just the previous year, and it offered both a larger and more powerful engine and more opulent coachwork to meet customers' demands for greater luxury and performance. 500K used the same independent suspension as had been introduced in the 380 with a double wishbone front axle and a double joint swing axle. Wow, that's impressive for the time. Coil spring and dampers a world first. Whoa, it's got struts. Cool. Consequently, it was more comfortable and better handling car than Mercedes' previous SS and SSK generations of roadsters from the 1920s, and offered greater appeal to buyers, particularly the growing number of well-heeled female drivers of the time. Pressing the throttle pedal fully engaged the Roots supercharger. Nice. Inducing the 5-liter straight 8 engine to produce up to 160 horsepower. That's pretty damn good for the 1930s. It's pretty freaking good, man. And making the car capable of over 160 kilometers an hour. 100 miles an hour in the 30s is pretty nuts, dude. While consuming fuel at a rate of up to 30 liters per 100 kilometers, or about 9.4 miles per gallon. 7.8 miles per gallon US. 3 different chassis and 8 bodies were available for customers. How many of these did they make? Of the combined production of the 500K, 342 cars, including 29 special roadsters during its 2 years in production, and the later 540K, 419 cars from Sindelfingen. Deliveries were 70 chassis without body, 28 open cars, 23 sedans with 4 doors, 29 sedans with 2 doors, 12 coupes, 6 Autobahn cruisers, Autobahn Courier, 58 roadsters, 116 Cabrio A, 296 Cabrio B, 122 Cabrio C. It's a nice car.
Discovery, go at throttle up.
Straight 8. Making 160 horsepower. How much torque did that thing make, though? Reza Pahlavi had one. Oops. Hey, Zarby. Dream car. Yeah. I wonder if the one in Speyer is like, if it's something like if it was somebody's car, like famous person's car, or an infamous person, I should say. Nice looking wheels, dude. Note that this car is technically mid-engine. The front axle is in front of the motor. Technically mid-engine. Cool, huh? The Germans still do that with some cars. Like Audi, for instance. Audi does this with their motors. Oh, yeah. Mid-engine car, technically. Edo burrito. And see, the other thing that I'm noticing is that Miura has some scuffs on it. I wonder what serial number Miura that is. That's right, Zarby. Leroy, did you read what that Miura is about? See, this is why when I go to museums, I like reading everything. I will sit there and read the whole thing. Yeah, it's all banged up. Okay, this website is terrible. That's good. Miura was Lamborghini's first car. Lamborghini was a tractor company. This is Technic Museum Speyer. How long after starting did it take you to get your driver's license? After starting what? What are you talking about? Let's go here. Quick search shows that some of the pictures of the Mercedes is being marked as an ex-Iraqi king. Huh. That's nice. Huh. Yeah, if you guys have ever listened to that song Panama by Van Halen, the car revving is a Mura S. The car was backed up to the studio and microphones were attached to the exhaust pipe to record the sound. Score. Nope, I was more interested in OKGLI. I saw its paint was in bad shape, but I don't know why. Yeah, I'm wondering. So usually when you see a car like that that's not restored, means that it has some historical significance, because nobody wants to restore it because all those marks were there from some historically significant event. Or they're just lazy. Maybe the museum doesn't have the money to restore it. Restoring a Mura is a very difficult thing to do. They didn't make a lot of those. Here, I found a Reddit post about it. Let's see. What happened to the paint? It got sanded down for a restoration, and then it was discovered that the car had been repainted different colors many times before. Further sanding it down revealed even more layers, up to 20, and it was decided to keep it that way as a museum piece. So they got lazy. Forlorn, you're not wrong. Yeah. New video from Relativity. We'll check that in a second. That's not paint. That's Bondo. I mean, let me see. Let me see. They said there was 20 layers of paint. So it looks like the top coat of this car, basically the last coat of paint that it was painted, was this Ferrari red, ironically. And you could see that it was painted, that's two-stage paint. See how it's darker right there? This I have a lot of experience in from painting parts. See how it's darker red right there, where they went over it with sandpaper, and then it's scuffed red, and then it's actual red? That's where the block sander, took pieces of it off. The reason why the paint has this like camouflage color is because of high and low points in the paint. That basically happens when you spray the paint if you don't spray it right. There's highs and low points everywhere, which I'll admit that this would take a long time to fix. A very long time. And it looks like underneath that red top coat was white paint. You see there's the red right there, and then there's white underneath it. It was white before that. Single stage white from what I can tell, because there's only really one shade of white. Actually, yeah. That looks right. And then underneath that was a stage of yellow. And then there was another yellow underneath that. And then gray. But see, that's just the body. That's just primer right there. Red, light red, white, orange, green, yellow, white. Yeah, Foz. This was all... Yeah, I mean, you're not wrong. This was all different colors. We still have to do that, J-Speed. And I will say getting 3 layers of paint off is very difficult. It's really difficult. I mean, you know, I will say it does look kind of cool. The car does kind of have a cell shading thing going on. It kind of looks like it belongs in Borderlands or something. They got lazy, making me the winner. That forlorn. That's literally it. They got lazy. They looked at all those layers of paint and said, "Nope, not doing that." Nope. No, it's fine. It looks cool the way it is. Yeah, I mean, you see how uneven that paint was applied? This is why it takes skill to do painting. Look at how bad that paint job is, because they level sanded it with blocks. Look at all the high points. That's what happens with this. You go at it with one piece of sandpaper. If you're uncovering multiple layers of paint with one type of sandpaper, it's a high point. Basically, like, if the car is right here, right, and then you have your layers of paint, like, say there's blue paint to here, and say there's orange paint to here, right? You ideally want paint to be applied nice like that, but there's high points like this. And then there's a high point in the blue underneath that. And that could be because someone painted over a dent in the metal. So when you go to sand this thing, right? When you go to sand this thing, the blue high point will show up through the orange paint. That's not good. That's not how you paint. That's really bad. And once again, really easy to tell. Look at all the high points. That's a terrible paint job. That second picture, okay, probably happened because their spray nozzle was a semicolon instead of a period. Anyway, enough about painting. Sorry, painting is kind of on my mind because painting is on my mind because I have to paint more parts for the truck out there. No, that's bad. All right, Thomas, what do you want me to see here?
Discovery, go at throttle up.
And then Vulcan will check out that relativity video in a moment. Falcon 9 has started prop load. Good, we're coming up on a Falcon 9 launch here. Hey, paint fumes do that to your mind. Yeah, you're not kidding. Paint support is coming your way. All right, so Thomas, what is this? In addition to recognize our Artemis 1 suppliers last week, I visited our vendors in Southern California to discuss future Artemis mission. One of those vendors? SpaceX. Great to talk with the team about the human landing system and dive deeper into individual components. Jim. Hello again, username. Did you miss anything? I don't know. What do you mean, did you miss anything? How am I supposed to answer that, username? Honestly, how am I supposed to answer that? I don't know when you were here last. Answer it yes. Yes. No, username, sorry, just busting your chops a little bit. There was a commercial space station announcement called Haven 1 today. That's the big news. And then we got a Falcon 9 launch happening very soon, amongst other things. That's your condensed version. They have 4 big screens to simulate the main windows of HLS with a main control screen in front of it. What? Isn't this Dragon here? I wasn't there at the start, so I probably missed a lot. I supposed to know that? Yes, Moist. You left 17.4 minutes ago. Did I miss anything? Yes, you missed 17.4 minutes. The 4 big screens have URL and tab names which say HLS. Bro. They do. Jeepers creepers. Only you would notice that, man. Only you would notice that. That's pretty funny, man. Quick, try the URL, see if they're public. Please repeat everything from good morning. All right, I'll repeat everything that I've said in this stream in 1 second. Did you get all that? Got it. All right, cool, cool. Good rundown. Yeah, I know. It's very descriptive. No semicolons that time. Vulcan, all right. Tee me up with that relativity video, buddy. Tee it up. Good way to do a rough and ready demo viability, though. All right, cool. So we got a new video coming from relativity. Let's see what we got here. Boop. 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 Hot. Oh, thank goodness she stopped. Did you not have your hot dogs ready to roast? You know, it's really difficult to use a rocket engine to cook something. You know why? Because rocket engines make a lot of heat on one side. So like if you put a nice cut of filet mignon behind the rocket engine, yes, I said it that way. Yes, I know how to pronounce it. Be quiet. If I did that, if I put a steak behind it, it's only going to cook one side of the steak. Putting a rocket engine would be a good way to pan-sear your steak. Yeah. And with that being said, I would pan-sear a steak. Steer a steak? Steak is a steering wheel. Englishman, I would do that. Yeah, I would absolutely do that. Put another engine on the other side. A rotisserie. You would need a rotisserie self-synthesis. Yes, yes, you would need that. Pan-sear your steer. Yeah, it's the same thing. Whatever. Did somebody say cooking with a rocket engine? Yes. Birthday candles lit. That I mean, yeah, the cake.
Anyone that's getting older understands that one of the most difficult problems is trying to figure out how to light all of those darn birthday candles on the cake. They melt, they burn you. It's actually a pretty difficult problem. To solve the problem, we've devised a, well, rather unique solution to light all of the candles at once.
Is this the content you come here for? I think you burned the cake.
Happy birthday, Max!
I'd eat it. Yeah, I'd eat it. Sure, why not? It probably tastes horrible. I'd eat it though. Max was the CEO of Firefly from a long time ago. Yeah. I would not eat a cake cooked in F-22 exhaust. Why not? It'll have a nice diesel-y aftertaste. It'll taste... Hey, diesel fuel doesn't taste too bad. Don't ask me why I know that. It tastes like dirt. It tastes like dirt. Probably because it came from the ground where there is dirt. Gasoline tastes horrible, by the way. It smells great. Tastes horrible. It tastes like metal dirt. Yeah, metal dirt. Yeah, that's the right way to say that. Metal, I mean, metal's also in the ground where there is a lot of dirt. All right, so we should be coming up onto this Vandenberg launch here, more or less, in a moment. Let's look at next spaceflight here. New Tesla video. Tesla. Oh boy. Probably foggy. Nah, it's the middle of the day. The fog only happens in the morning. So this is a new video from Tesla.
Right now we are in UAE, in Dubai Service Center, where we conduct field testing for Tesla.
The climate here is
Discovery, no
special.
throttle.
It's
Junk.
very warm, so it's part of the reason why we're doing testing here.
Dubai is warm? Okay. Peepo G.
We are focusing mainly on mileage accumulation, hot weather related tests, as well as product launch testing.
So we like to test these cars here. We also do the same in Norway during the winter. The main goal of this test is to make sure that these vehicles will survive at both extreme conditions, cold and hot. We'll be safe for every conditions we have in between these two.
We're actually driving per day between 250 and 400 kilometers to make sure we have a long distance and we stress the car a lot. So now we finished the supercharging, which means we need 100% for this tour today. And we run out to Jebel Jais, to the mountain. Hopefully everything goes good today. Let's see.
That looks like New Mexico. Yeah.
I am collaborating with
Just a
the
random
field
thought.
quality engineering team from Berlin. We're testing Model Y here, and at the same time we have a US Model X Plaid. Right now we're in Ras Al Khaimah. It's an emirate about 150 kilometers from Dubai.
We are at Jebel Jais. It's the highest place of the UAE.
We are about 1,400 meters above sea level here.
UAE is perfect because the climate is consistent. It's always super hot.
Extreme humidity, extreme heat.
Earlier today it was 51 degrees. So
Bit off on that one. I know, it's Dubai.
pretty hot.
You don't really find this climate anywhere
You
else.
smell burnt
It
toast
can be
by
very
any
dusty
means?
one day, so we can
Like
have
by any- or
sandstorms
by any
or
chance?
dust storms. It can also get
Smell
very
burnt
humid,
toast,
up
do you?
to 80–90% humidity sometimes.
The hot climate is really challenging for the vehicle because it has to cool the battery, the drive units, and also it's really important to keep the passengers cool.
So we'll charge the car numerous times.
Red Bull.
We'll use the AC as much as possible. We'll use cabin overheat protection. We use all the features of the vehicle.
Cool.
We'll park it in the sun for a long time. We'll charge it superchargers. Why are we using black cars? Because black absorbs more heat.
Yep.
So we want to take the car that's most likely to suffer.
We're trying to find everything that would impact the customer from bumper to bumper. Here we are on the mountain road. So we have a steep incline, which is really good to test the chassis components, for example.
There's lots of twisty turns all the way up the mountain. It's a continuous drive up, so it puts a bit of strain on the powertrain, cooling, air conditioning, all sorts of things.
Going uphill, that costs a lot of energy and it's turning into a lot of heat. That's perfect for testing the thermal system.
Don't worry, but you've got a Hornet on your shorts. He's gone.
While testing conditions are pretty intense, the heat, sandstorms, it's a lot of big bees around here, also goats that we're not used to see really often.
We are here right now in UAE because it is the worst time to be in UAE. It's the hottest time of the year. The weather is no fun. It's 50 degrees Celsius some days.
Oh.
You cannot go outside in midday sun. You would burn. It's just too hot. No one wants to come here in the summer, but it's a great time to test a car in hot climate.
I do. Interesting video. Now, the real question is, will a Tesla work on Mars? Because some of that terrain, though, you know,
UAE, it's the
some of that terrain. I mean, that kind of looks like Mars to me. I think it's crazy to think about how rare rocket launches were in the 2010s, and now SpaceX is launching like 5 times in 10 days or so. Yep. It's awesome. Arandelario, 19-month resub. Thank you very much. Tesla is the only car that might work on Mars. I mean, yeah. Okay, so we're just waiting here for the Falcon 9 launch. That's a really old picture, Erudite. Honestly, I think cooling will still be the biggest problem on Mars, no convection. If I recall correctly, that Mars copter is limited not by battery capacity, but by not melting the motor. Yeah. Something like that. Random question. Is Polaris technically an internal SpaceX actual program? I would call it an internal mission with private funding. Yeah. That's what I would call it. Could they use a Tesla motor and battery on a rover-like vehicle? Yeah, Midget, I don't see why not. I mean, it should work. You might have some trouble with the battery cooling system, though. Yeah. Speaking of SpaceX, EJ Chat, what are your current estimated number of Falcon 9, Falcon Heavy flights for this year? I currently have 87 to 90. I'd say 75. 1075.3 is flying today. Yeah, here, let's get the deets for this mission. So this is from Next Space Flight here. This is flight out of Vandenberg, 1075, boosted 1075. the 75th Falcon 9 to be manufactured. It's going on its 3rd flight, and it's going to land on, of course, I Still Love You, 38-day turnaround. This mission is the 68th orbital launch attempt of 2023. SpaceX's 234th mission, and their 30th mission of 2023. This is Falcon 9's 223rd mission, and its 28th mission of 2023. I just want to point out here that we're under halfway through this year, and SpaceX has already launched 2 Falcon Heavies this year. Just putting it out there. This mission will also be the first time Go Beyond will be dual purpose, acting as both drone ship support and fairing recovery. Cool. Dang it, man! I have today off. I should have driven up there. That's on you, Rezel. The 3rd one is in July. Yep. That's crazy. That is a crazy amount of launches. Yeah, High Vise, you said it right, man. It's pretty freaking cool. The thing has gone to space this year more times than I've been to the grocery store. Nick is debating on making pizza. I wish they could hammer out the center core recovery, though. Yeah. Yeah. Soon. So we're just waiting on SpaceX here. Let me get the title changed up. SpaceX Starlink 2.9 launch coverage. All right. Stretch stage 2 and stage earlier. At RC Quest, which was the previous Dragon 1 recovery drone ship support and fairing recovery vessel, will be retiring after 8 years with SpaceX. Crazy. The next Falcon Heavy is dual drone ship landing. Dual drone ship landing? Is the center core gonna make it into orbit or what, man? Dang. That's crazy. SpaceX is live in 3 minutes. I know, Nova. I have it up. Do you think it's possible to land the side boosters on one drone ship next to each other? Contra, I would say it could be done, but I'm going to go ahead and say that... Oh, jeez, stop yawning. I'm going to go ahead and say that maybe, probably not. They'll probably never do it. Alright, I need more water. You guys are making me yawn. Somebody yawned and then I yawned. Don't lie. I don't know what it is. It's some missing link stuff. I know when you yawn. It's very strange. Matsuro, damn it, man. Get fresh pots? Yeah. I'm out of coffee. I have to go down to the house if I want to get more coffee. I missed that. Dual RTLS, my bad. I was going to say, Phil. Yikes. All right. Just got my coffee. Won't happen again. Good! Wasn't me. You passed it on to me. No, I didn't. You passed it on to me. Alright. What else is on the docket here? Let's see. Oh, look. Starlink, Starlink, Starlink. Oh, okay. Fantastic. Okay. Oh, it's on Sunday. Oh, Saturday night into Sunday morning. Nice, nice, nice. So you need a garage coffee maker. I didn't say that I didn't have that, Gaw. I said I don't have any coffee up here. I have a coffee maker in here, absolutely. I'm not yawning. I'm breathing in 4K. Ah, all right. I'm gonna say that. I'm gonna say that from now on, Gil. That's a good way to put it. Man, you think SpaceX launches a lot? Starlink, Axiom, Arabsat 7. Would it make sense to put super heavy landing flight computer with added entry burn because Falcon to test super heavy flight computer, or would it not make sense? Would it make sense to put super heavy landing flight computer with added entry burn because Falcon to test super heavy flight computer, or would that not make sense? Interesting change. AX2 will be RTLS instead of drone ship. Huh. No, it would not make sense. But Erudite, they're probably using Falcon 9's flight data to get super heavy to land. That's why we haven't seen any like Grasshopper style super heavy tests. We probably won't. SpaceX is online. All right, here we go. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding. The Ranger is getting a Raptor variant with 405 horsepower. I love how the Ranger is basically just an F-100 nowadays, Hellfish. I would not call that a mini truck at all. It's not a quarter ton. That is a half ton truck. It's an F-100. Can you imagine a Booster 9 Grasshopper flight takes off, goes out over the ocean, comes back to be caught, never going above 5 kilometers? I think that would be a good way to test the chopsticks, Jax, but yeah. All these old vehicles, they just keep putting on inches and yeah. Quick deploy today, as they will do a single burn on stage 1 with deploy at T plus 17 minutes 21 seconds. Cool. Yeah, Jax, I'd be in. That would be a fun time. Wow. Oh, man. Okay. Drink more water. Water. Hydrate, you nerd. I'm working on it. Get off my back. When do you think SpaceX will default?
Nice launch trajectory countdown.
Hopefully
That is
never.
clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic. Stage separation confirmed. Dragon separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
for tuning in to today's Starlink webcast. Falcon 9 is set to deliver another 51 Starlink satellites to orbit from Vandenberg Space Force Base's Pad 4 East in California. And today's mission marks SpaceX's 30th launch of the year and 229th overall mission to date. And hello everyone, my name is Chris Rhodes and I am a structures engineer here at SpaceX. At T-minus 4 minutes and 40 seconds, the teams are currently tracking no issues with the vehicle or spacecraft. Weather is looking good, and the range is also ready to support liftoff time of 1:09 p.m. Pacific time.
Guys, I run ads here to make sure that people don't get ads during the launch. Like, we'll run it in the, when it's counting down, to make sure that people don't pop into the stream while the rocket's launching and then see, an ad for something you probably don't need.
Environment with teammates from a diverse set of backgrounds with varying perspectives and mindsets,
where
everyone can work in a welcoming environment where all voices are equally heard. And today's launch and the rocket on your screen could not have been possible without such a team.
I don't know.
At T-minus 3 minutes and 50 seconds, the clamp arms have fully opened beneath the second stage, and as you can see on your screen, the strong back has began retracting away from the vehicle in preparation for takeoff. As we head into the last few minutes of our countdown, it's worth noting that there is a chance we may lose coverage during today's mission. And if we lose views and telemetry, we'll likely have to end the webcast a little bit early, but we're crossing our fingers that all goes well. And we are currently waiting for Stage 1 LOX load completion, which will wrap up in about 20 seconds.
Hey, Bobby, what's going on? Yeah, see, during the day out in California, the marine layer's cleared. It's really only in the morning where you get that really bad fog.
Stage 1 LOX load complete.
Pretty.
At T-minus 3 minutes, Falcon 9's first stage is now fully loaded with RP-1 and liquid oxygen, and we're now waiting for completion of LOX loading on the second stage about 50 seconds from now.
This is Vandenberg.
Once that's complete, that will wrap up propellant loading on the vehicle.
This is Vandenberg Space Force Base. You're looking at pad, this is Slick 4E.
And the white clouds that you see circling around Falcon are completely nominal and the result of our super chilled liquid oxygen coming into contact with the relatively warm ambient air at the launch site, turning the liquid oxygen back to its gaseous state.
Yeah, it's California. Liquid.
And again, we're waiting for Stage 2 LOX load completion, which will wrap up at T-minus 2 minutes.
Nice name. This is just to the west of Lompoc, California, guys. 2 years, Lompoc. I'll die before I go back. It's about 100 miles northwest of Los Angeles. I'm sorry. I'm sorry. That's pretty funny. It's a funny name.
Stage 2 LOX load complete.
What's up, Sub? How you doing?
Falcon 9 is now fully loaded with 1 million pounds of fuel
Lucy.
and liquid oxygen.
It's so true.
It might be worth noting that we may not get certain views from our second stage camera today after takeoff, but we'll plan to show as many views as we possibly can. And the booster you see on your screen is flying for its third time today.
Okay, so what they're doing here is a ground gas closeout. Okay, that's a ground gas closeout, meaning that... Oh, there's the drone ship. I got a little bit of chop out there today, just a little bit. That ground gas closeout means that the second stage is ready to go. It means the tanks have been topped off. What SpaceX is doing there is getting all of the oxygen, albeit, when it hits the atmosphere in gaseous form, out of the lines. You don't want the propellant in here when the rocket goes to launch, because when this thing disconnects, it usually has some residual pressure in it, and, when you disconnect it, it's like disconnecting a pneumatic hose, like it goes, psst, right? And that usually sprays propellant everywhere. Depressurizing the lines mitigates that, because you don't want your launch pad lighting on fire when you go to launch your rocket. The launch pad has to be reusable too. It's important to understand. Okay. 20 seconds.
15 seconds. T-minus 10, 9, 8, 7, 6.
Sound suppression system
5,
should turn on.
4,
There it
3,
is.
2,
Green
1.
flash.
Engines full power.
There it is.
And liftoff of Starlink. Go Starlink, go Falcon.
29 is flying. We got a launch today. And the propellant caught on fire on the pad. Nice.
Vehicle is pitching downrange.
Okay, everything looks good here.
And with the chamber pressure is nominal.
Seems to be a little windy down there in Southern California today. It's okay. It's a dry heat wind. 30 seconds in, looks good.
At T plus 30 seconds, Falcon 9
Should
has
get a power and
successfully lifted
telemetry
off
call
from
here in the
Space
next
Launch
10
Complex 4
seconds.
East at 1:09 p.m. Pacific Time.
What's up, Doom?
Power and telemetry are nominal.
There it is. It's a bit breezy, Jono. Okay. There we
Falcon
go.
9 is supersonic.
All right.
And as you just heard, Falcon
Very
9
nice.
is now supersonic, meaning that it is traveling faster than the speed of sound.
Maximum dynamic pressure.
Max Q.
And you just heard the call out for max Q, and this means that the vehicle is currently experiencing the greatest amount of external stresses as it ascends through the Earth's atmosphere that it will see during its flight today.
Very nice. Very nice. Into the clouds.
And we are about 1 minute away from a series of events being MECO, stage separation, SES-1, and fairing separation.
Them clouds, though.
MECO stands for main engine cutoff, which is when all 9 Merlin engines will shut down in preparation for stage separation. And during that point, pneumatic pushers will separate the first and second stages, and the first stage will begin its journey back to Earth, while the second stage will light its Merlin vacuum engine, making second engine start 1 to propel our Starlink satellites to their planned orbits. And shortly after, the fairing halves will separate and fall away from the vehicle to later be recovered. And let's keep an eye out for these events happening in pretty quick succession, about 15 seconds from now.
Yes, let's. There's Lompoc down there.
Discovery, go at throttle up.
Or maybe Lompoc's over there. Can't really tell. The plume is in the way. Yep, there. It was burning slight radial out. Did you see it turn down for main engine cutoff there? Class, 56 months.
MECO. Stage separation confirmed.
All right, everything looks good. Turn down for what?
And back ignition.
Good ignition on the second stage, from what I can tell there.
Fairing separation confirmed.
And with those callouts, we can confirm MECO, stage sep, SES-1, and fairing separation. And although we didn't have views of fairing separation from the second stage, we will be attempting to recover both fairing halves using our recovery vessel, Go Beyond. Both of the fairing halves flying on today's mission are flight proven and are flying for their second time.
Why they didn't show the fairing separation. It's a little weird. But we did get a shot of the fairing separating from the ground. If that helps. Maybe it helps a little bit.
Both vehicles continue to follow nominal trajectories.
And there you heard that stage 1 and stage 2 are both following nominal trajectories. And currently, the first stage is on its way back to Earth towards our drone ship, Of Course I Still Love You. And if successful, this will mark our 190th overall landing of an orbital class rocket. And the MVAC engine attached to the second stage is continuing its burn, which will last another several minutes.
It's Catalina Island. There's a Catalina wine mixer. It's over there. I mean, you can't see Catalina Island, but it's close enough. Wish this was at night. I could see the flight path from your backyard.
On the left side of your screen, we have views of our first stage as it's making its way back to our landing site. And the right side has our MVAC engine on the second stage, which is performing nominally.
Okay, everything looks good here. What is that island? Those are called the Channel Islands. They're a bunch of islands off the coast of Southern California, near Los Angeles. Is the fairing interior pressurized during launch? No, Syncos. It actually has, there are holes inside of the fairing to make sure that that doesn't happen. It's a pressure vent. Because basically as the rocket gets higher, the gas can get trapped.
As you can see, we have 2 out of Falcon's 4 grid fins in view on the left side of your screen. And they measure 4 feet by 5 feet and help guide our booster back to our landing site by actively changing the vehicle's center of pressure.
Our channel islands are better. I don't know. Ours has the Catalina wine mixer. So basically what happens, Syncos, is that there's holes down at the very bottom of the fairing. So the fairing is like kind of a cylindric shape. It's conic at the top, and then it kind of goes in at the bottom. Right towards where it goes in, there's 4 vents on each fairing. And basically the gas, think of like water draining out of a tank. As the rocket goes higher, the gas will leak out of those vents. And it'll basically depressurize the fairing on the way up, slowly.
And as a reminder, Starlink is a satellite internet constellation designed and manufactured by SpaceX to provide high-speed, low-latency internet to people living in remote and rural locations all around the globe. The next major milestone we have coming up is the beginning of our entry burn on our first stage, which is scheduled to occur around T+6 minutes and 40 seconds.
What's the ring on the vacuum nozzle? This Zymus, it's just a seam right there for the material that they made the nozzle out of. If you're talking about the ring that's separated at ignition, that's called a stabilizer ring.
You also may be noticing white puffs of gas from the bottom of our first stage, which is nitrogen from our attitude control system, which also helps us control the vehicle's descent.
The stiffener ring is basically there to make sure that the nozzle doesn't wobble around.
Both vehicles continue to follow nominal trajectories.
When the second stage is attached to the first stage.
And again, we're waiting for the beginning of our stage 1 entry burn around 10 seconds from now.
Say the thing. Sit. No, I don't want to now. You forgot to say.
Stage 1 entry burn startup.
You didn't say please.
And there's the call out for Stage 1 entry burn. And Stage 1, which we also call the booster, has ignited engines 1, 5, and 9 to slow it down for atmospheric re-entry. And this will be a short burn lasting another 10 seconds.
Say the thing, please. Supersonic retro propulsion. That's the heat shield. That's the heat shield, guys.
Stage 1 entry burn shut down.
Falcon 9's first stage.
And you just heard the call out that the entry burn on the first stage has completed.
Does re-enter.
The first stage, used to launch our 51 Starlink satellites into space today, is flying for its 3rd time, having supported the Space Development Agency's Trans-Zero mission and one
Stage 1 FTS has saved.
So
and one Starlink mission previously.
That rocket firing its engines is actually pushing the plasma out of the way. Falcon 9's heat shield is the exhaust gases. Oh, a little windy. Upper level winds. Whoa, okay.
And coming up next, we will have the start of our landing burn, second engine cutoff, and the landing of our first stage booster.
Stage 2 FTS has saved.
All right, we're back. Oh.
Stage 1 transonic.
Okay.
And you just heard the call out that the first stage is now transonic, meaning it is traveling nearly the speed of sound.
Drone ship's under the left grid fin right there. See it?
The second engine cutoff and the first stage landing attempt will happen in quick succession, so keep your eye out.
Stage 2 terminal guidance.
Stage 2's closed loop. See the drone ship, it's under the left grid fin. Okay, there we go.
Stage 1 landing burn.
And there's confirmation that the Stage 1 landing burn has
Oh,
started
it's
in
windy.
preparation for landing on our drone ship. Of course, I Still Love You,
it's
which
windy.
is coming into view.
Oh, it's windy. Come on. Landing legs.
Stage 1 landing leg deploy.
That's impressive, dude. That's just dang impressive,
Stage
man.
1 landing confirmed.
And back
Dude.
down.
That's impressive. Wow. That's nice. Look at up. Yep. Oh, there's
And we have
the
a nominal orbit insertion.
vent down. We got a call
And
for
Falcon
nominal
9
orbit
has
insertion.
successfully
You see
landed
how-
on our
see
drone
how
ship.
windy it
Of
is?
course,
See
I
the thing
Still Love
rocking
You.
around?
And this marks our 190th
Dang.
overall landing of an orbital class rocket, including Falcon 9 and Falcon Heavy missions.
That was a
And
pucker
if you heard those
moment for a
call-outs,
second
we also
there.
had a successful SECO and nominal orbital insertion. With confirmation of successful first stage landing and good orbit from our second stage, that will
Right.
wrap up our coverage for today's Starlink launch. Be sure to check our social media for confirmation of Starlink deployment. And as always, thank you so much for watching, and we will see you soon.
People leave. No bullseye landing. Dude, we got... No, screw that. We got to see that one more time. That was impressive, dude.
And the first stage landing attempt will happen in quick
Look
succession,
at this,
so keep
man.
your eye out.
Right, Simon? It's still crazy, dude. It looks like it's gonna crash until the last second where the grid fins kind of dial it in there. That's nuts, man. Oh my goodness, that is a lot of aerodynamic stress right there. The grid fins kind of weeble wobbling around, man. Ah, that stinks, Rennie. Oh. Whew. It is definitely windy, dude. Look at the shadow. The wind's blowing the thing around, see? Look at the wind blow the thing around, dude. Man. Show chat the giant Roomba. They have concerns. There's a little tractor thing that they have on the deck of the drone ship that comes out and grabs Falcon 9 and anchors it to the ground, guys. Don't worry about it. It's literally probably popping out of its garage on the drone ship right now. We might be able to see the garage here. It's called the Octo Grabber. It grabs onto Falcon 9's hold down points, the things that hold it to the launch pad. Its garage is behind Falcon 9. It's over here. There's a blast deflector here, and the blast deflector opens up, and it looks like a little Roomba. It comes out, and Falcon 9's attachment points are right there. They're in between each landing leg. They only bring the tanks down from flight pressure for a couple seconds. It's not very much. Yeah, I say little. The thing is like the size of a gigantic tractor. It looks little compared to Falcon 9. Switching it dang close for leg deploy. Was this another batch of V2 minis? I'm not sure if this was V2 minis. I did not see the payload. They didn't show it, dude. Yeah. Weighs as much as a tank. Yeah, it's a pretty big vehicle. So that was the Starlink 2.9 out of Vandenberg. Yeah, everything seems to be good there. They should be coming up on deploy here in the next 10 minutes. Can you show the wobbling? Yeah. Sure. So it looks like it lands, right? And then you could definitely see it wobbling around. And then it looks like the shadow kind of stops. And then you could start to see the wind blow it around. See the shadow? See what I'm talking about? It's definitely windy. I don't know, Podwee, maybe. Yeah, why wouldn't they show the payload? They said that they would have spotty coverage, so that's probably because of the ground stations, if I had to guess. On windy.com, you could check how windy it is. So they would have recovered somewhere down here. No knots. SMH my head. About 20 miles an hour. That's not too bad. Not too bad.
Discovery, go at throttle up.
Drop a pin. 20 miles an hour, Adam, give or take. So we have 20 mile an hour winds. Actually, right now it's 15 mile an hour wind with gusts up to 20. Wind is going south-southeast. It looks like heading 120 or something like that. 120, 135, something like that. Hey, Reshok, 43-month resub. Select the higher level and have fun. Oh. You can really get crazy with this, huh? Look at this. Huh. Okay, that's not too bad. I'm not sure how to see upper level winds here. There's a slider on the right hand side. Yeah, I see it now. Upper level winds are going east. Actually, the upper level winds are about the same. Yeah, just anywhere from like 15 to 20 with gusts up to 20. That's not bad. I wonder why that it was so violent going down through re-entry and stuff. Those aren't upper level winds. The shadow moving around has more to do with the wave action. Yeah. What causes waves? Oh, yeah, Mayor. Yeah, that's right. Yeah. Upper level winds are 70 miles an hour, gusting to the east. Which explains why the booster was trying to go this way. It tried to veer off in that direction. Hey, Angry, what's going on? Today, by chance, I helped Ariane 6 go to space. Helped the application for heavy transport. Helped their application for heavy transport. That's cool, man. Right on. Neat. I've created a monster. I knew about windy, Adam. Thank you. I didn't know about the upper level winds part, though. I'm going to start looking at that before every launch. Yeah, windy is cool. Absolutely. What do you think about Ariane 6 cryolocks? I think it's a good design. Here, I'll switch us back over to EJ's Space and Rocket Review. I think it's a good design. I would be remiss in saying that, you know, it's probably a good design for... I'm trying not to be a jerk. Like, it's a good design, and if it does what you need it to do, then it's a good vehicle. But it seems like the markets that Ariane 6 is designed to serve are not there anymore. That's my thing. It seems like the European space, or not European, Kness would have been wise to have Ariane 6 up and running in like 2017, 2018, somewhere around there. Because the market that Ariane 6 is trying to serve is, like I said, it's not there anymore. And if there is any demand, people are just going to use Falcon 9. See, so that leaves... But, you see, here's the interesting thing. There was a time where the Europeans literally owned the commercial market for launching satellites. Seriously, Ariane 5 is way less expensive than like its U.S. counterparts, like Delta IV Heavy and Atlas V at the time. Delta IV Heavy and Atlas V were used to launch... they were used to launch like national security payloads, something that Ariane 5 can't, so that left the commercial market open for Soyuz and Ariane 5. And they did eat up a lot of the commercial market, and then Falcon 9 came along. Now, the other thing that's important to understand is that while Ariane 5 cannot do Department of Defense missions for the U.S., it can do defense missions for the European space, for the EU, basically. So they can launch spy satellites with it. And Europe does want to maintain its own domestic launch capability. It wants to maintain its own domestic launch capability. So even though Ariane 6 is not really, like I said, the market for it really isn't there, I don't think, it's still going to get made because the Europeans need it for defense. Because being able to launch yourself, being able to launch your own stuff into space is really important for a country's national security, or a government entity, I guess. Thanks for the thoughts. Definitely interesting. Yeah, I honestly think that Ariane 6, like, I don't mean to be a jerk, because, once again, rocket science is difficult. It's hard to do. It's hard. This is easier said than done. Way easier said than done. And I don't want to be disrespectful. It's not my style, especially when it comes to rockets. Ariane 6 is a good design for 7-8 years ago. Like, and don't get me wrong, I don't think this is... Anybody that's following spaceflight would know this. But sometimes this stuff takes longer than expected. That's an important thing to understand. Sometimes that's just the way it crumbles. Like, I don't think I could do it any better. You know what I mean? It's a good design for probably about 5 years ago, I'd say, like, at the very least. Like, if it rolled out in 2018, 2019, it would have been great. It'd be great. It'd be a great design, very competitive, but do you think it's going to be easy converting Slick 6 for Falcon architecture? Yeah, should no more than converting 39A was. In fact, 39A might be a little bit more difficult. Wait, you could develop Ariane 6 in your garage? Maybe in Kerbal. Ariane works in a manner that's not good to keep up with the real commercial market. They are still too tied to their governments and depend strictly on them, which slow down everything due to budget. Yeah, I mean, yeah, true that. I think we should straight up copy Starship at this point. Human person, I mean this in the most respectful way that I possibly can. I don't think you can. I honestly do not think you have the industrial base to support a project like that. And I'm not trying to be mean. You definitely have the greatest minds, but there's not an industrial base to manufacture something like that. You'd have to build something like Starbase. I'm not saying you don't have the technical expertise. Europeans can make rockets. Oh yeah. You take that as an insult. Yeah, you know, you said you did exactly what I said not to do. I said don't take it as an insult. I don't think you have the industrial base to do it. Super heavy launch vehicles are something completely different. I'm not saying that you couldn't make it. I'm saying you don't have it right now. That's all. Interesting, Aqualix. To be honest, I feel that Vulcan and Ariane 6 are like 5 years too late. New Glenn is even a bit behind. But I believe its reusability, if it works out, puts it ahead of Ariane 6 off the bat. What I mean is what you think the reason is a lack of will. That's the only problem. Yeah, there's also that. And that's the hard one to overcome. I mean, human person, once again, I don't think the industrial base is there, but I'm not saying you guys couldn't do it. Germans are pretty damn good at that whole industry thing. Yeah, pretty damn good. The industry could be made. You guys just gotta want to. I'd rather they make a Venture Star copycat. The industrial base is totally there. Oh, okay, point me in the... Alright. You're not understanding what I'm saying. Okay, point me to your Michoud, please. Where's your Michoud assembly facility? Where's your VAB to build a super heavy launch vehicle? Where's your super heavy launch pads? Where are those? That's what I mean. That's what I mean about the industrial base. I never said you didn't have the technical expertise to do it. You don't have a VAB. You don't have a Michoud assembly facility. You don't have a Marshall Space Flight Center for testing rocket engines at that scale. Do you see what I'm talking about? You don't have launch pads that are big enough to support something like this. No way. Where are you going to build them? In Kourou? Okay. Do it. Please. What do you mean the industrial base isn't there? Infrastructure. That's what that means. We could build infrastructure. I know. Now you're just parroting what I said, but you're pissed off. Where can Germany launch east? I can think of a location. Germany had a fairly sizable space center at one point on German soil. At one point. I mean, human versus is the same thing that I say about the Chinese. Anybody here that thinks that China wouldn't be able to build a rocket to get to the moon is foolish. They'll do it. They'll definitely do it. They're not doing it right now, though. You're not going to build a rocket to go to the moon without all the things that go with it. Yeetage confirmed. Good, we got a good deploy on the Starlink satellites. I've heard Peenemünde. Peenemünde is not a bad location for launching, but you're really kind of limited in your flight azimuths there. But yeah, that would be a place where you could do it. I'm pretty sure in this day and age, no one would want anything launching over the Baltic Sea because it's a huge shipping lane. China has landers on the moon. They've done that, just not humans. Yeah, but Forlorn, there's a lander that's the size of a little, you know, Power Wheels thing, and then they're sending people to the moon. Don't. I see what you're doing. Don't. Those are two different things, and you know it. Stop. No, Michoud? Insert Megamind head. Yep. Why has no one just bought and used the rusting Venture Star linear aerospikes? Because it's Lockheed's and Aerojet Rocketine's intellectual property. You'd have to license it from them. Is there any actual reason to send people to the moon? Send people to the moon other than prestige, though. Rovers can bring back rocks just fine. Why climb Mount Everest? Why, a number of years ago, cross the Atlantic? City Robo do it because, you know, it's a point of national prestige. It serves as a beacon to show the world what we can do as a country. That's why we do it. Why does Rice play Texas? Yeah. Why ask why when how is so much more fun? I like that. Do launches from Florida have to do an inclination correction since Florida is above the equator? Yes, Jack. If you're trying to get to an equatorial orbit, sure, absolutely. Now, where you do that on-orbit plane change really matters, though. If you do the on-orbit plane change in low Earth orbit, it's going to cost a pretty penny of delta V. If you do a geostationary transfer orbit insertion launching due east out of KSC, which is 27 degrees north latitude, you're going to get into a 27 degree inclined orbit with the apogee at geostationary. If you line up your apogee on a geostationary transfer orbit with your descending node, basically you cross the Earth's equator right when you get it to geostationary height or geosynchronous height. You could do an on-orbit plane change out there when your orbital velocity is very low because you're at the highest point of an orbit, your kinetic energy is minimized and potential energy is maximized. Basically, you're going slower. It's easy to turn when you're going slower. So yeah, absolutely. That's usually how they do it. Stay on how they do it. Geostationary orbits from inclined landing sites or launch sites. Yeah, Kyron, I know. There's a certain country that would be upset if they launched east. Yeah, I know. Wait, I thought due east out of KSC is 27 degrees. I thought it was 28.5. So, username, there's these things. There's these things at KSC. There's the launch pads. The launch pads are not all in the same spot, so it can vary from 27 to 28.5 because, you know, the launch pads are all up the coast. The science, you yield more science sending people to the moon. Yeah, there you go. I wish I knew what that word salad meant. Sounded cool anyway. Watching space, I can simplify it if you want. Alright, so let me load up Google Earth. I said let me load up Google Earth. Jeez, I'm going to be on Twitter. Get this crap off my page. Okay. Alright, so take a look. Check this out. Kennedy Space Center. See all the pads that I was talking about? Up all the coast? Yeah, see? Actually, username, yeah. It looks like it goes from 28 all the way up to 28.3, but doesn't matter. So we're at 28 degrees north latitude here. So if you launch due east out of KSC, right? Let's just use the path tool. and set the path tool, or no, let's use line because line has heading. So if we take that, and obviously the heading needs to be 90, right? Keep it at 90. Right? You launch due east out of Kennedy Space Center, you're going to get into a 28-degree inclined orbit. Now, what does that mean? Well, if we look right here, so we got to use the longitude and latitude here to, and this is where we'll use the path tool. Right? That's the equator right there. See that? Give or take, this is where the equator is. The angle that this makes is your inclination of your orbit, okay? The inclination of your orbit is where your orbital path crosses the equator. What's the angle? So, launching due east out of KSC will get you into a 28-degree inclined orbit. So, see what I'm talking about here? You need to, watching space, basically, you need to take a left-hand turn in space. That's the thing. You need to go from this trajectory to this trajectory. Why? Well, geostationary orbits need to be around or near, well, geosynchronous or geostationary. They need to be around or near the equator. So they need to be basically on the 0 line orbiting with Earth. Basically on the equatorial line. Now, don't get me wrong, you can have synchronous, which can go up and down on different latitudes and stay relatively synchronous. That's fine. But if you're making something in geostationary, it's going to be on the equator. So launching due east out of KSC is going to get you to cross the equatorial plane here at 28 degrees. You have to take that left-hand turn in space. See this left-hand turn? If you do that in low Earth orbit, where your orbital velocity is 17,500 miles an hour, well, you have to take a left-hand turn going 17,000 miles an hour. Not easy to do. Right? Yeah, you have a lot of momentum that's making you follow the white line, and you need to be on the yellow line.
Go and throttle up.
Right? So, what satellites do is... Here, hold on. Or what rockets do... Give me 1 second, I gotta... Here we go. This is stuff in space. So if we go here and we select SpaceX old Falcon 9 stages, here we go. There's one. Check this out. Look, it looks like this is a Falcon 9 second stage. This is a trajectory from a Falcon 9 that was launched, a second stage that was launched in 2017, right? So you can see approximately the line where a geostationary orbit is, right? It's where this white line of satellites is. Now, take a look. This is a geostationary transfer orbit, right? So what the rocket will do is it'll launch, but if you notice, it's 25 degrees inclined, or it's close enough to 28, right? They made a change when they did the insertion orbit. They made a slight inclination change, probably for some better performance. So basically, the second stage started to take that left-hand turn that I'm telling you about, but what happens is the rocket will fire and it'll push the highest point of the orbit pretty much out to geostationary apogee. Now, in orbital mechanics, the apogee is the slowest point of your orbit. Perigee is the fastest point. Perigee is the point where you're closest to the celestial body. Apogee is when you're furthest away. Perigee and apogee in orbital mechanics is a trade-off between potential and kinetic energy. Long story short, at apogee, you slow down. You slow down because the planet shot you back up here, you go really, really fast, and you weren't going fast enough to escape, to break the grav well. So you'll start to slow down, and the grav well will pull you back in. It's like if you took a tennis ball and you threw it up in the air. For a momentary second, that tennis ball, when it stops and gets to the highest point of its arc, it's maximize. It has maximized potential energy. It's technically just sitting there for. It's just for like a millisecond, though, right? Same idea. Now, don't get me wrong. This thing is not at 0 meters a second velocity here. No. Not at 0 meters a second. It's closer to whatever the orbital velocity is out at geostationary, because it would be 0 relative to the ground. But long story short, you're going a lot slower out here. It's easier to make that on-orbit plane change. It's easier to take that left-hand turn like this when you're going 1,000 miles an hour as opposed to 17,500 miles an hour. Does that make sense? It's easier to take the turn out here when you're going slower because Earth's trying to pull you back in. You're going a lot slower up here. You're going very fast down here. Yeah. Now, with that being said, SpaceX did do a mission where they took the left-hand turn in low Earth orbit. They did a mission like that a little while back. Which mission was it, fellas? They made that left-hand turn, and it was insane. Yeah, it was the IXPE. Thanks, Ian. So, the Imagining X-ray Polarimetry Explorer. My mouth did not move that fast. So, check this out. It was a great launch. This was about a year ago. So watch what happens. See, they launched due east out of Kennedy Space Center, right? Watch. Look at the trajectory. See what I'm talking about? IXPE did the left-hand turn in space, in low Earth orbit, which is an insanely high delta V requirement, but they did that because IXPE is it was a very light satellite. So watch. Notice how the rocket engine is firing, but the speed is not changing very much. Because they're not so much speeding up or slowing down, but they're taking that left-hand turn. Pretty crazy, right? And they could afford to do this because IXP is very light. It's a very low-mass satellite. See, that engine is firing full blast and the velocity really isn't changing because the trajectory is changing. This is called this is a normal burn. It's literally called a normal burn. There's normal and anti-normal. Well, this is on the descending node, so they would have to position the... Actually, this is an anti-normal burn. They were on descending node, so anti-normal. Basically, the spacecraft's going this way. They pointed it that way to go that way. Take the left-hand turn, and that's exactly what they did. See that? That right there takes a lot of fuel when you're going this fast. But yeah, watching space, that's what I'm on about inclination and flight azimuth, etc., etc. Yeah, that was, once again, that's the IXPE mission. Really cool mission. Super successful. IXPE is still up there. It's still doing its thing. And it's going to be for a little while. You see that? Pretty crazy, right? But there's a reason why. There's a reason why I drew this right here, because I had a feeling somebody was going to ask if that's ever been done. Yeah, it has been done before, but they usually do this out of geostationary when your velocity is way, way less. Pretty cool, huh? Also Starlink. Can you talk about that satellite that goes Can you talk about that satellite that goes around the sun to bounce off somewhere else? I heard that it will exceed the highest speed of a satellite ever built. Yeah, Lobato, you're talking about Parker Solar Probe. Parker Solar Probe is the fastest human-made object ever. It grav-assisted off of Venus, I think, and it achieved a speed of, I think it was like 400,000 miles an hour. That's really, really fast. And yeah, that thing is designed to... Guys, correct me if I'm wrong here. It's designed to penetrate the solar corona, if I'm remembering right. I think. Yeah. Study the solar corona. So the sun has gravitational pull like everything else, right? And the sun is constantly ejecting out gases, right? And because the sun has such a high gravitational pull, a lot of those gases just fall right back down onto the surface of the sun. Some of the gases get ejected at escape velocity, right? And that's what solar winds are. So basically the sun has an exhaust plume, just like any other power plant, right? And some of it is shooting out fast enough to be able to break the sun's gravitational pull. That's what solar wind is, but most of the gases get pulled back down inside of this basically the sun's grav well called the solar corona. That's where Parker Solar Probe is. It's actually skirting the solar corona, which is really cool. Actual dumb question, but is the velocity measured off the sun or off the Earth? It would be using the Earth as a local reference frame, awesome dude. Yeah, because if we were using the sun's reference frame right now for speed, we'd all be... the speedometer in your car, if you were going 70 miles an hour down the highway, would be reading 66,770 miles an hour. Yeah, the Earth is going pretty fast right now. We don't notice it because speed is relative. And that's basically how spacecraft fly. They need a reference frame. They need basically a starting point. And the starting point does not factor into account Earth's orbital velocity. I hear that's how fast Mac's car goes with the DRS open. You'd be at the sun pretty fast if that was the case. And there's public confirmation that SpaceX has ditched the upper ring of landing engines and that they will just use Raptors to land on the moon. What? I wouldn't call that a confirmation, Thomas. The design could be in flux. How did you forget this? Was this on one of the monitors? Did you do a enhance? Enhance. 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 Do you guys remember watching X-Files back in the day and how they were like, oh, the resolution on this security cam is no good. We can't make out the guy's face. All right, enhance it. Yeah, that's not a thing. Actually, AI can do that nowadays, which means the X-Files was way ahead of its time. Use the Samsung Zoom function. Oh, God. Last week was busy. I started this week in Southern California to recognize our Artemis 1 suppliers and discuss future missions with our vendors, including SpaceX. With over 500 companies and 16,000 people, more people in California work on Artemis than in any other state. You can make an educated guess. You can't recover information that isn't there. Yeah, I know, guys. I went to school for that stuff, remember? It was a joke, but okay. Not a very funny one, I guess. Now, Thomas, my question is, what are these things on those nacelles? Yeah, I know what people are going to say. Oh, well, that's the landing legs. Well, why is it in the engine indicator category? Ah, Tidris. Tidris? Tidris? Tidris. Tracking, that's NASA's tracking data and relay satellites. They wouldn't be able to reach something out onto the moon, I don't think. Starship trajectory there. Also interesting, Thomas, the heads-up display has a Starship with wings on it, with the flaperons on it. I guess Tidris can aim outward? Yeah, that's new. Yeah, also ground tracking, right? And the ground says 1202 on it. Curious. Curious that it has that number on it. Tidris is facing in the wrong direction. No, I know that, but yet we see a SpaceX Starship lunar landing simulation here that says it has acquisition of signal through Tidris. So, yeah, what are we going to do about this there, pal? So, yeah, Thomas, I would go ahead and take everything here with a grain of salt, to be honest with you. The Starship graphic has the wings on it. HLS doesn't have the wings. How can you be at the moon with a winged Starship? At least initially. Just eventually it'll probably happen. I bet the software there is a reskin version of something they already have. It looks like Dragon's flight controls, to be honest with you. This looks like a placeholder Dragon. These are Dragon. This is Dragon's flight controls, dude. Also, you can see the reflection of Jim over there. What was the worst space mistake you've ever seen in a movie? Gravity is up there, not because it's a bad movie. Gravity is a great thriller movie. It's not sci-fi; it's a thriller. That's important to understand. So, if it was a sci-fi, I'd be like, no. The reason why is that whole left-hand turn thing that I told you guys about. So, they go from servicing the Hubble Space Telescope to the ISS. The Hubble Space Telescope is 28 degrees inclined. And the ISS is 51 degrees inclined. Which means at some point, the spacecraft needed to make that left-hand turn in space, and they never did that. They just, we're magically at the ISS now. We're talking about probably a 7 kilometer a second delta V normal burn to get from Hubble to the ISS. And that's actually a pretty conservative estimate. Actually, it's probably a little less than that. But still, you would literally need like a Saturn V second stage to be able to take, like, to be able to change your velocity like that. You'd need like the S2 from the Saturn V to do that type of on-orbit plane change. He also said you wouldn't have Clooney flying around like a space cowboy. Yeah, the man maneuvering unit. Untethered EVAs are not smart unless you absolutely have to. Armageddon is pretty bad. Yeah, that's pretty bad. In Armageddon, they say, we need to accelerate it, blah, 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 for blah, blah, blah amount of time. One time I had chat, actually it was Yarg. Yarg did the math out, one of my buddies that watches the stream. Yarg did the math out and realized that if they accelerated at like 9 Gs for like 20 minutes, that they'd be near the sun. Now, don't get me wrong. It's not that that's not possible. And I don't know, 9G sustained for that long would probably hurt somebody in ways that we don't understand. But also, we have nothing that has that amount of power. Yeah, you might as well say we're going to make the jump to light speed here. Yeah. It's Alex. Listen, I've played Kerbal, and the amount of times I've used EVA to get myself into all sorts of orbit, I think it's pretty realistic. Oh, yeah, of course. We have stuff with that amount of power, though. Your farts. Martian is pretty good, Bials, yeah. Armageddon is a NASA training video. No, it's not. No, it's not. No, it's not. What's going on, Etal? How you doing, buddy? Jeepers creepers. That's stupid. That's pretty dumb. What was great about Gravity was the movie was so quick and the pacing so rapid that there was no time to break down the logic until after the credits rolled. You know what? It's like you wouldn't expect it from me. I thought it's a good thriller movie. It's a great thriller. Keeps you on the edge of your seat, that's for sure. It's just not very realistic. But thrillers don't have to be realistic. You know, like, yeah, it does. You don't have. It doesn't have to be that way. How and what location in an orbit do they match inclination with the ISS? They launch into the ISS's inclination, Zarby. They wait until the ISS passes overhead, and say the ISS is passing over Florida, and it's going from southwest to northeast. When the ISS, or its orbital track, gets over the coast of Florida, they launch going northeast. How accurate is Apollo 13 since we are on movies? Is there anything like glaringly wrong with it? No, Apollo 13 is pretty damn good. Except Jim Lovell didn't say, Houston, we've had a problem. No. What happened is the spacecraft exploded and he basically said, well, that's not right. Houston, I think we've had a problem here. Oh, we're venting. Yeah. Houston, yeah, we've had a little bit of a problem here. Yeah, we're venting something. Yeah, that's not good. Yeah, he was basically a lot more cool about it. I mean, I don't know about you, I'd be a little annoyed and probably a little scared if my spacecraft just exploded, but it's all right. Oh, you should, yeah, Alleviate, you should hear it. For the 50th anniversary of Apollo 13, we listened to Apollo 13 in real time. That was a number of years ago at this point. But if you listen to the chatter, yeah, he's just like, yeah, we've had a problem. We're venting something. What are we venting? Oh, oxygen. All right, yeah, Houston, we got a little bit of an issue here. But it wasn't like in the movie where the spacecraft blows up and he's like, we've had a problem. No, not like that. Nah, Jim Lovell's way cooler than that. Houston, we got a little bit of a funny. Yeah, also, the reason why Apollo 13 happened is because some bonehead dropped the frickin' thing dropped that O2 tank before he put it in the spacecraft. Didn't tell anybody about it. Whoops. Yeah. Oops. Turns out introducing cryogenic oxygen to a Teflon seal with a source of ignition makes great rocket fuel. Was it level or swipe? It was gym level. Gym level. No, Naps, you got to keep your cool when you're on. You got to keep your cool when you're in space. You have to keep your cool. You can't freak out. You don't freak out. Don't panic. Seriously, panic is just gonna screw everything up. And yeah, while they're trying to figure out what happened, you know, Gene Kranz said on the flight loop, he goes, "All right, everybody, don't freak out. Let's figure out what happened. Work the problem. Figure out a solution." Like, people were like, "Oh no, this isn't good. This is." He's like, "No, shit, this is. We'll take care of it. It's all good." That's not the first time someone dropped something and something went boom, right? Yeah, it's happened from time to time, Malone, where somebody's like, "Okay, I'm going to install this component." Oh! Yeah, all right, I'm just going to install this. Oh. Yeah, no, that's happened before. It's always something stupid like that. You'd be surprised. You know, you expect these crazy, grandiose failures, but like the Vega mission. There was a Vega mission last year. They launched a Vega into space. First stage performed great. Second stage ignited. Everything was good. Actually, this may have been 2 years ago. And the second stage ignited, and it was supposed to do a orbital raise maneuver. So it's supposed to pitch up. It pitched down and went right into the ocean. Yeah. Oops. Somebody crossed the wires. I'm serious. That was the problem. Someone crossed the wires on the thrust vector control system. So when the computer commanded the nozzle to make the thing pitch up, it pitched down and went right into the ocean. Oh yeah, that happened. It's always something stupid like that. Cooler heads prevail every time. Yep. Yeah, there's that thing. Yeah, Thomas. Yeah, that freaking ghost satellite. Yep. There was a Proton launch back at, 2014 or 2013? The rocket launched and literally nosed right back down and went right into the ground. Somebody installed the guidance system upside down. Actually installed it with a hammer would probably be the right way to explain that. So the rocket launched and it was like, wait a minute, I'm pointing towards the ground. Literally when you don't have the right control point in KSP, but in real life. So the rocket did what it thought it was supposed to do. Because the guidance system was installed upside down and it thought the rocket was pointing downwards, it tried to reorient the vehicle and literally nosed it right into the ground. Oh yeah, stuff like this happens. There was a Delta II launch in 1997. Launching a GPS, I believe, a global positioning satellite. Somebody dropped one of the SRBs and cracked the casing. Didn't tell anybody about it, so when they went to launch the thing, the SRB worked for a couple of seconds and then it burned. The SRB casing could not take the pressure of the engine ignite, and it basically opened the crack and the whole rocket exploded and then rained fire down on the Cape. Yeah, don't drop SRBs. You guys want to see that one? That one's my favorite. We've had an anomaly? You gotta secure the area? Like, it is one of the craziest things you've ever seen. Watch this. Here. It was caught on tape. I don't know if you knew that.
6, 5,
Watch.
4, 3, 2, 1. 0. We have ignition and liftoff from Cape Canaveral Air Station of the Air Force Delta II launch vehicle carrying the new GPS-2R satellite.
Okay, so it's kind of subtle. I don't know if it's very subtle. It's hard to see the SRB casing fail. It'll happen here in just a second. You gotta look really close. Did you miss it?
We have had an anomaly. We just had an anomaly of the Delta II launch vehicle from Cape Canaveral Air Station. We need to secure the area.
Maybe? Was that a question?
Once again, we had liftoff of altitude launch vehicle from Canaveral Air Station, and we just had
Run!
on the pad.
Run! Oh my god, if I saw that, I'd be running. Oh my goodness. I wasn't at the wedding flash shows. I was at my bachelor party. Yep. 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 I don't know if you guys saw it. The failure was kind of subtle. It was kind of hard to see. Oh! Oh no! Yeah, I'll post the link in chat.
Anomaly of the Delta II launch vehicle from Cape Canaveral Air Station.
Yeah, it costs a little bit, Tessa.
We need to secure the
Dude, the raining fire part is the part that gets me. It's like,
once again, we had liftoff of Air Station, and we just had
blew up.
Problem with
Oh
the
my
vehicle on the pad.
Wait, what did she say? Hold on.
And we just had a problem with the vehicle on the pad.
No, you didn't. So, an SRB caused that? Yeah, when an SRB blows up and blows up the other 7 SRBs that are on it, yeah. SRB fuel burns hotter than thermite, guys. Yeah, it's pretty hot stuff. Yeah, it's I think she's in shock. Yep. Just on the pad failure problems secure the area? Yeah. Yeah, the one with the backwards sensor. It's the IMU, the inertial measuring unit, was installed upside down. Literally reversed control point in KSP. Yep, that's exactly what happened. I'm in danger. Yeah, pretty much. Dude, that is just... Whoever was the director of this and decided to switch the camera here needed a raise. That's unbelievable. Look at that.
And we just had a problem with the vehicle on the pad.
Crazy, right? Regarding the count from 10 to 0, is it true that this is done because they need to leave Earth's orbit at the specific hour, minute, and second? It depends. It depends on the mission, Lobato. It depends on where it's going. So, like, ISS, sometimes the window is instantaneous to the second. Because, once again, taking those turns in space will use up all your fuel extremely fast if you're not careful. And the rocket needs to be as light as possible. It's only going to carry enough fuel, as much fuel as it needs to get to where it needs to go, with maybe a tiny, tiny bit of margin, just to be sure. So sometimes launch windows are literally down to the second. Sometimes launch windows are down to the minute. Sometimes they're down to the hour. Sometimes you can just launch it whenever you want. It depends on where you're going. Yeah, right, Hellfish? It's crazy. Yeah, well, yeah, right. So, yeah, it really depends on where you're going. Guys, launch windows mostly are for getting either A, the right transfer orbit to the right slot in geostationary, or B, getting to a certain inclined orbit. Yeah, here, I'll show you again, Lovato. So let's go Zarya. So the ISS is 51.6 degrees inclined. That's the type of orbit that the ISS is in. It is a very weird tilted orbit at face value. When you look at it, you're like, why is it in something like that? That's weird. The reason why the ISS is in this type of orbit is so all the international partners to the program can get to it. Europeans can get to it from their launch site in Kourou. Obviously, we can get to it from KSC. The Russians can get to it from Baikonur, which is right here. And the Japanese can get to it from Tanegashima, which is over here. It crosses, the ISS goes over all 4 of those points in space. That's why they chose to put it here. So basically, the Earth is spinning underneath an orbit like this. The orbit doesn't go with the rotation of Earth. You're doing this, and the Earth is spinning underneath you. So the orbit will only cross over the Cape at certain times. Now, ideally, you want the ISS to be flying over Florida when the orbit crosses the launch pads, right? But sometimes it doesn't. Sometimes the timing is a little bit off, right? So, for instance, the ISS is over there. It's sitting out over New Guinea right now. And obviously, you are not in a launch window for the ISS right now. If you tried to launch out here and then take a left-hand turn in space like that, you'd need a rocket twice the size of the Saturn V to be able to do something like this. So, and that's just not efficient. That's really stupid. Why would you do that? Right? So you have a launch azimuth, right? So going out of the Cape, instead of going this way, they would go that way. They go up the coast when they launched the ISS. Every single shuttle mission did that. Every shuttle mission went northeast that went to the ISS. And they'll basically wait, because Earth is spinning underneath the orbit, they'll wait until Florida crosses that orbital plane, and then they'll launch. And sometimes that's down to the second. Oh, yeah. Looks like America got the worst site, though, a lot further away than anyone else. Jack, the Earth spins underneath the orbit. The orbit... This yellow line will keep moving to the left. Yeah, no, it's all good, it's all good. Okay, yeah, chat delay, I got you. That's a lot of junk in space. That's nothing, dude. If you were sitting right here... If we're in a spacecraft right here at this altitude looking at Earth, you would not be able to see a single one of these things. It's just, yeah. Simultaneously here, if basically, if every one of these dots was to scale, it would probably be about the size of Manhattan. Yeah. If every one of these dots here that's used to indicate a spacecraft is to scale. Yeah, it'd be about the size of Manhattan Island. Yeah, that's the scale that we're talking about here. Yeah, space is very big. What are those yellow lines? Starlink satellites. The yellow trains of satellites, those are Starlinks. Yep, this is just kind of a graphic representation of all the different things all the tracked pieces of debris and satellites that we have in space. The gray stuff is debris. So like this one, this is an Ariane 4, Ariane 44LP debris. Something that it was launched it was the 109th launch of 1988, and it was an Ariane 4, and it was a geostationary mission. That's probably just a rocket body. The reflected light from the sun, Tessa, would wash it out. You wouldn't be able to see it. It's only in the right lighting conditions that you can see satellites. You can see a lot of satellites on the Terminator, basically at dawn and at dusk. In the right lighting conditions, you could see them, and they're everywhere. And it'll literally look like this going across the night sky. It's really cool. Or the dusk sky, I should say. Yep. Satellites and stuff, dudes. Pretty cool. Orbital mechanics is pretty sweet, man. What were the pieces of the rocket that were falling off when the grid fins deployed? It's solid nitrogen, Gujar. It's not pieces. It's solid nitrogen. When you outgas nitrogen into the vacuum, it goes through a very rapid phase change before it goes to nothing, because vacuum. In that very rapid phase change, it goes from gas to liquid to solid in literally a split second. That's what happens when you vent high-pressure gas into a vacuum. It'll solidify very, very fast. Satellites are the coolest, I've decided. Yeah, in the right lighting conditions, guys, you can see the ISS go by. If you have good eyesight, you can see the solar panels with your own eyes. You can see them. It's very tough to do it, but you can see it. Absolutely. How long would it take to get rid of the space junk? Yes. I don't know how to answer that, Jonathan. I mean, what are we talking? Are we talking about getting rid of every single satellite? Like, what does that mean? Getting rid of all the debris up there would take years if we did, take years. Can space junk protect us against meteors like a shield? Nah, Lobato. The problem with that is that if a meteor comes in, a meteor isn't just one solid. It's not like a cannonball. A meteor is just a bunch of ice. It's just a bunch of chunks of ice just kind of being hurled in one direction, right? Or that's basically a comet. Meteors can be one big solid rock, but usually, here's the thing. Usually it's a bunch of rocks, right? It's not like completely solid. It's like if you think about like an asteroid or something. If you took like wet sand and you made that wet sand into a ball and you threw it, it's basically a loose amalgamation, right? And if whatever it hits, it's just gonna pop, right? Asteroids are like that. So if we had an asteroid hit like a second stage, a broken second stage, or an abandoned second stage up there, it basically would shotgun blast that second stage, and then that second stage would just turn into a debris shower. It would do the opposite. It would make it worse. Yeah, you got to be careful about that, because if like one stage, if a piece of debris hits another piece of debris, it'll shatter, and then it's just a shotgun blast of debris. And if that finds another piece of debris, the debris cloud will get bigger and bigger and bigger and bigger, and it can compound over time. And eventually it could compound to the point where no one can launch anything into space without literally making your spacecraft able to withstand a 17,500 mile an hour impact from something. Bulletproof? No. Orbital velocity proof. That's called Kessler syndrome. It's something that can happen. No, it doesn't happen right now. Gravity shows what happens. The movie Gravity shows what happens when Kessler syndrome hits a resonant, not a resonant cascade. That's Half-Life. Has a cascading effect. That's what Kessler syndrome is. Showered by the debris of collided spacecraft. It's not good. Gravity is Half-Life 3. That's what I'm trying to tell you. Yeah, well, you don't want Kessler syndrome to happen. That's the reason why we don't fight in space. That's the reason why there's no military bases in space or military bases on the moon. Because Soviet and American scientists figured this out in the 60s, that this can absolutely happen, and you definitely don't want it to happen. So they signed the 67 Outer Space Treaty, right? And that basically limited people from putting offensive weapons in space because of that, for this exact reason. Now, if you've ever seen a show like The Expanse, those point defense cannons that they have in The Expanse, think about what that's doing. You're shooting out rifle cartridges at orbital speed. That's not good for launching things into space. But then again, in The Expanse, they have ships that can clearly take it. So, hey, Whitney, thanks for the raid. A long time ago, I heard that the human being could place an atomic bomb in space to wait for some kind of threat coming to our planet. It would explode and protect us. Have you heard about something like this? Would it work? The detonation wave from a nuclear blast, Lobato, could push things in different directions. Yeah, of course. Yeah, absolutely. That could do it, sure. But there's that whole, 1967 Outer Space Treaty basically saying you can't do that. You shouldn't, don't do that. Whitney, what's going on? Thank you for the raid. What were you up to? It's why when some stupid nation decides to have an anti-satellite weapon and blow up a satellite in orbit, it really, everybody hates them. That's right. That's right. No problem. You were doing the weekly challenge. Did you get it? There would not be a detonation wave. Neumes are small, and there's no medium for the wave to propagate in. Oh. Oh, you clearly know your stuff, Ando. There's that whole Orion drive thing. What does that do? You know, that thing that shoots nukes out the back and then it has a heat shield to ride the detonation wave of a nuke in space. What about that? You know, that there's that whole thing? No, that doesn't happen, though. Not yet, Whitney? Oh, okay. Yes, but at least the explosion would alter the trajectory. For something bigger than planet Earth coming our way, if an asteroid the size of Earth is coming toward us, Lobato, there is literally nothing we can do about it. There's nothing. There's nothing. There's nothing we can do. A nuke, shooting a nuke into that would be like about as annoying to that thing as like a fly would be to us yet. Yeah, that's not. No, we just can't generate that amount of energy to move that much mass. We have nothing that can do that. There's nothing to my knowledge. There might be something out there. I don't know. I was only doing the spacecraft and the rocket. I'll do the mission tomorrow, Friday. Right on, right on. No, the detonation wave actually comes from the superheated air. Nukes are actually pretty crap space weapons. The Orion drive actually uses a nuclear-shaped charge where they pack the device in a way to generate gas and propel it at the pusher plate. Oh, so that doesn't generate a detonation wave. Thanks for that. Thanks for that important safety tip. Are you drunk? Good safety tip, Egon. Don't cross the streams. What are we playing or doing next? This is a useless conversation. Anyway, Hearts of Iron SVO? I mean, how did the front axle work go? Okay, so truck update. I found some funnies with the front axle, namely the plate. So my truck has disc brakes in the front, and it was a conversion. The caliper mounting plate is mounted on 3 bolts. There's 2 up here and 1 down here, right? And then the kingpin is right here. 2 of those 3 bolts have a nylock washer or a nylock nut on them, a stop nut, and they have about maybe 1 thread. The bolt is going into 1 thread. So there was literally a bolt that was held in place with a nylock washer with no nylock engaged. And it was on 1 thread, holding the disc mount caliper plates in there. Yeah, that's probably not good. Yeah, that's on both sides, by the way. So I did find a little bit of a funny with the brake caliper mounting brackets. I got to go buy some longer bolts. So I did find that, but I'm happy I found that. Other than that, we did... Yeah, I gotta hang the leaf springs and stuff. I'm probably gonna, but I gotta clean up the axle. The axle's covered in grease and stuff. And yeah, I'll probably clean it up and give it a quick coat of paint and then call it a day. But we do need to take the brakes apart so I can get at those bolts so we can get a longer bolt for the caliper bracket. Yeah. So yeah, we got to do that. I'm gonna do the cleaning up and stuff. I don't know. We might do it on stream a little bit later tonight, but I remember the rotors looked like they needed to be cleaned too. Yeah. Do you have a segmented brake reservoir? Yes, Sawyer. It's power brakes and a master cylinder from a Corvette, from a C3 Corvette on the 59, yes. You'd love to see some Wings Wednesday? All right. Okay. I don't know. Were we going to make an F-104 or something? We could do Wings Wednesday. That's fine. That's right. Didn't we rebuild that on stream? I tried to rebuild it, and then I wasn't confident enough in me rebuilding a master cylinder, so I bought another one. We could do that. We could do, yeah, we could make an F-104. Pretty sure we could get that done pretty dang fast. Actually. Yeah. Yeah, let's go ahead and Wings Wednesday it up. That should be good. I can't build that part, though. Maybe later. Damn. Are we making a starfighter? Yeah, sure, why not? Let's switch over